YouTube's live. Hello, YouTube. Hello. We're going to be doing the ADS implementation exam 2018-2019 as practice for the for our implementation exam. You're allowed to use book notes and everything that's on Brightspace, I think. So yeah, let's just get started. Somebody made a request that I do the graph question first, so I'm going to do that one first. And without further ado, let's go ahead. Input method counts vertices, where it takes a graph and a vertex as input and returns the number of vertices in the same connected component of the given vertex. Your implementation needs to use breadth first search. The method should return null if the graph or vertex is null. So now we can do that real quick. If g is null or v is null, return 0. And otherwise, it asks us to do a breadth first search implementation of to go through all the vertices, which makes sense. I'm really quickly gonna log in to the. I'm just gonna do this in the way I would also do it in the exam. You guys are allowed to interject and like add stuff to it, and like send screenshots or whatever. But this is just I'm just gonna go with how I would do it during an exam. So what I do in an exam is I have just a tab with the videos and also the PDF. So let me just open that up. So for when we need it, let's have a look at the video.
Executed our total for.
And here we have like literal pseudocode we can copy. Woo. Okay, so we have a let's see. So we have a depth first. Or a breadth first search, not a depth first. So this is DFS. Then we're gonna skip through the video, and there we go. So we create a set and a queue. So we have a set of graph.vertex, namely this is known, I think. New set. I'm not sure if set is actually a thing, but we import java.util.star. So if it is a thing, we will get it. And otherwise, we create a let's see, a queue of graph.vertex. Queue is new. And I think for queue, you're not you can just do new queue because there is no queue. Oh, I forgot these. There is no queue data structure in Java, right? Let's actually check. So if I do save now, it should give an error.
Yeah, no, there's no queue. You need a linked list.
Yeah, I was about to say what I indeed did was just using linked list, and I don't know about sets. What
you're gonna have to use a hash set or something like that.
Yeah, if you don't notice, you let's see, are we allowed to use the
I think we're allowed to use JavaDoc.
Yeah, in the JavaDoc I would just look for set. So actually, let's actually do that.
I think it's abstract if I remember correctly.
It's
either an interface or just abstract.
Where's the
they link it at the start of the exam as well.
Oh, that's a good one actually.
Have
So in this one,
up one.
Oh, okay, yeah, that makes sense actually. So
then it's I think in assignment. The tab assignment in the actual exam. I think is where they link it.
Oh yeah, we can just go to another exam, so we can go here.
Yeah, there it is.
Not the flex with my 6.8.
Nice. That's like twice as good as I did on the analysis.
Fair. Enter this one, graph. And all our progress. Oh, it's still there, poggers.
You could also just look up set JavaDoc and then open the first link.
Yeah.
Yeah, but now you get the proper JavaDoc.
Yeah.
Of like the exact version they're running and stuff.
Yeah, exactly. Like if you show, if they also like, hey, actually this is hosted by David Delft, so if you use another one, they might complain. But yeah, I think if you just look for set, like eventually you'll find.
You know there's a search function in the JavaDoc page, right?
Depends where.
Wait, there should be.
Yeah, there should be. In the ones I know, there is, but
There is normally one on the right.
Yeah, indeed.
Maybe Ctrl 0 to zoom out, maybe?
Hmm?
Should I zoom out, maybe?
Oh, shit. Control 0. No, I'm in like no zoom.
Oh, okay.
Okay, well apparently
Well,
their search
apparently
function is
theirs
fine.
doesn't. Whatever. Don't they usually use like the Oracle Javadoc?
I think so, yeah.
I think for OOP they used the Oracle one, yeah.
Yeah, because that's where I remember it from. Anyways, it doesn't matter. Just remember set as a hashtag, a queue is a linked list, and the rest you can just use
Yeah.
the implementations you want. Okay.
The doc you were just at was the Javadoc 8, and with OOP we use Javadoc 15.
Yeah, because they're still using 8 for ADS apparently.
Yeah. So we
Actually, try that. Try to use var instead of a defined function or defined type.
Oh god, okay. For x equals 1.
No, they're using Java 8.
Of course, why would we allow? Okay, known dot add our vertex, not named v, and q dot add v, I think would be proper syntax. Let's see if it's complaining. Oh yeah, and it must return a type of int, return 1. Okay guys, that's it. That's the assignment. Let's see how far we get. No.
But you're doing
28.
final 89.
28, at least 28
That's
points.
still
one
pretty
forward.
good.
We're
That's still
halfway
pretty good. I mean-
there. Whoa! In
That's 1/4 done.
Just trial and error and hard code the solutions for each spec test.
For the people genuinely thinking that doesn't work, but it is pretty
No.
funny.
That's sadly.
So we can say while then we take the queue dot is empty and then we invert that. So while there is something in the queue, we take the graph dot vertex current vertex equals q dot remove. I'm gonna see if that works. Then this should just work. Local
I think I'm
yeah,
missing
okay, that's
brackets
just
here.
things that are not used, but it does work. So now we have this thing, then we can visit, so we can say total plus is 1. We can say and then we go through all the edges and we add them. So we can say for and we can go to the library real quick to see how that works. Okay, yeah, so get neighbors returns an array list, and an array list is an iterable. So we can say for and this returns. Oh, okay, so this is just all of the vector. So you don't have to do any annoying stuff with like edges instead of vertices. So you can literally just do get neighbors, and it will give the neighbors of an edge. Okay, cool. So we can say for graph dot vertex other vertex in current vertex dot get neighbors. I probably butchered the spelling. Don't mind me. And then I do q dot add other vertex, and then I add the oh, actually I forgot one step, because now we're adding everything. We should do if known does not contain that. So if not known dot contains other vertex, then we can add it to the queue. Because if we don't do that, then it's just gonna add everything infinitely many times, and it's not gonna be pretty. Because a node is its own neighbor's neighbor. Then we do known dot add other vertex. Save your tests. Hey, the method get neighbors is not visible. I probably misspelled it, didn't I?
It's private.
Uh,
Private.
It's a private. It's
Oh
a
damn it!
private.
How do I?
Depends.
wait,
Would they
never
get
mind.
really annoyed at it?
It's
At people
probably
using
get neighbor.
reflection?
Okay, yeah.
Yeah.
I get it. So it's the graph dot get neighbors and then the vertex. Because we have to use this function. they abbreviated neighbors to nay.
Nice.
Yeah, okay, so it's graph dot get neighbors vertex v. So and now we return our total. Save your tests. Expected 3 but found 4. Spec tests. Less than what we had before.
1 is better.
Okay. So let's see. We had a test that wasn't working. That's good because then we know what's going wrong. So we have test example. This one. Expected 3 but was 4. Is there anything we're not doing with the list of known vertices? Maybe we should add itself to the... No, this should just work. For all edges in the outgoing edges, if not known, dot contains. Okay, let's have a look at the test. Which one, on which line is it working? Or is it not working? Well, that's really easy to see. It's one of these 3. So if
I think you should have total equal 0, not equal 1.
Oh
You
yeah,
need to-
yeah, because you added the first node twice.
Oh,
Yeah.
I see, because I added to the array. Yeah.
Yeah.
Or to the queue. That's a good one. Key 9, thanks guys. Cool, 100. 10 minutes in,
That
guys.
was easy.
But wouldn't our test be a bit harder since this one wasn't meant to be open book? I think.
Probably.
It
I
would
think.
probably be a bit harder, but not
Yeah,
that
but
much harder.
it's still a good way to like show how it would work. Also, if this test takes less than an hour, I'm just gonna do another one.
Yeah. Okay.
So let's see. In the assignment, you implemented count nodes even children, which counts the nodes of a tree that have an even number of children. Okay, so it takes a tree. Oh wow. Oh, that have an even number of children. Okay. It doesn't say anything about the big O notation. That's always a good sign. That means.
So how about we just loop over everything 5 times inside of each other?
Dude, what we do is we say I is equal to 0, and then we do while I is less than a million. No. I mean, even then, if I just did like a bunch of time lost in the middle, it wouldn't scale with the size of the tree, so it would still be 01. It would take 10 years, but it would be 01. Okay.
Big O notation is fun.
If tree is null, it should return null. Cool. Only nodes that are non-null are counted as children. Let's look at the methods of our tree. Oh. Okay, cool. So get children returns a list of library tree. And this is a library tree, okay. Well, I mean, this wouldn't be too hard. So we can say number of nodes in the tree that have an even number of children. Okay, so now we can do depth first or breadth first, or we can just do recursion. But I really don't feel like doing that.
I mean, I have a question. If
Okay.
a node has 0 child, does it still count as even numbers or?
Ooh, that's a good one. So if it,
I think
Let's actually look
a
at the
node
test.
with 0 children is considered a leaf.
No,
Yeah,
let's look here. So if it has 0, if it has 0 children, then only the root exists, but the root has 0 children, which is an even number, so it returns 1.
Oh, okay. Well,
Yeah, whatever.
That's
We'll
fun.
take the W. That's good. So
And if it doesn't work, try seeing it as no, just
yeah.
so if it doesn't if it sees no trees as odd for some reason, and yeah.
Okay, so let's see how we'll do it. It's not a binary tree or anything, so it's just the amount of children. I guess we can do breadth first again. So we can have we'll create a queue. I'm just doing this like by heart, so we'll see what comes from it, but should work fine. A queue of library trees. Queue is new linked list. Let's say total is equal to 0. And since there's no way we can get back to ourselves, there's no need to have a known library, known set. So we can just say queue add tree while q dot or while not q dot is empty. For okay, so now we can do get children, right? Yeah, okay, so we can just say for library tree other tree in get children, or yeah, okay, we to be fair, it would probably be nice if we had a current tree. Is q dot remove. It's really nice that they have these types as iterable. My brother only just found out about these, like about iterable and about this notation, but it makes everything so much cleaner. And then we just say q dot add other tree, and we should realistically only do this if current tree is not, or if other tree is not null, because leaves can have null children, or I'm not sure if they can actually, but I'm just gonna put it in for safety measures anyways. It can't hurt. So okay, now meanwhile in here we have to do the visit. So then we can say total or int. Actually, we could just use. No, okay. I was thinking of using the dot size or the dot length or whatever function of array lists, but we also have to count how many non-null there are, so we're gonna have to loop through them regardless. We actually already do that here, so I might make use of that. So I can say int temp is 0, so that's the amount, or let's call this int non-null children is 0. If other tree is not null. My indentation is fucked and I don't understand why, man. What do you mean?
WebLab does that sometimes. It's really weird.
Okay. There we go. That should be a bit better. Okay. So if other tree is not null, that means that this tree has a non-null child. So we can say non-null children plus plus. And then eventually we can say if non-null children modulo 2 is equal to 0, then we can say total plus is 1. I use plus plus and plus is 1 interchangeably, and it's gonna bother a lot of people. So then we can say return total. Save your test. 3 out of 3. 100 out of 100. Anyway, 17 minutes in, guys. I do think it's gonna be a lot harder, like the other ones than this, because this is like almost disappointingly easy. What about the points? Yeah, this is 3 points. This is 4 points. Huh. Odd.
Perhaps you could do an recursion version as well.
Oh yeah, I could. Let's see if there's like a question that would warrant that. For now, it's not needed yet, but ooh. Okay, it needs to run an O1 times. You may assume that every string in image average null so that's good. We have to implement a least significant digit first radix sort algorithm to sort a sequence of Dutch mobile phone numbers in non-decreasing order. Okay, so we need to implement LSD radix sort, and we need to make it ON. There's already more more requirements. So let's grab the video about radix sort. Where was that? Or didn't they call it like bucket sort or something?
It was a week 6, I think.
Ah,
Yep.
Key-based sorting. Thank you. Yeah, radix sort, LSD, MSD. Cool.
Applicable bucket keys of types other than
What a scam. They don't even give code. I have to use the other code of the other one. SMH. Previous video. Bucket sort.
and some
I think they also give the
interesting.
implementation in
I don't
the book.
think. Yeah, I think there's implementation in the book. I do remember, but I don't think there is in the
Yeah.
video.
Most likely. That makes sense actually. Okay, let's see. What would be the best way to do this? Okay, let's actually need to look in the book. That's probably smarter. So let's have a look at LSD, MSD. What do you mean? Maps, hash tables, list. Wait, where would it? What if
Oh,
I
it's in
search for
12. I
Sorting
think
and
it's
selection.
chapter 12.
Chapter
Is it
12.
chapter? Yeah.
Yeah, sorting and selection.
There we go. There we go. Linear time sorting, radix sort, and bucket sort. There we go. Thank you very much. Let's see. So, okay.
That's bucket search though.
Yep. Okay. Okay, that makes sense actually. So, now the question is, how do we do that for LSD and MSD? Do we just do it recursively? Or like, in this case, we only need to do it 8 times, but then for every nth digit?
You just do it for every digit, yeah.
I see. Well, let's first start with making a bucket sort for 1 digit. So let's see, a number is 10 numbers, and the first 2 we can ignore. So let's see, we can start by making out the buckets. And the buckets have to be, does it matter if it was like FIFO or LIFO, like a queue or a stack or a list or whatever?
No, I don't think it matters.
Okay, I think
It's
it does matter for the stability of the thing, but I don't think we care about stability here. Since like a 5 and a 5 will be the same thing, since they're just strings. So it doesn't really matter. So we can create a let's do the buckets will have 10 buckets of yeah, okay, so we can create lists of strings and then have an array of 10 of them.
But it's a bucket sword. Is it the same thing as radix sword?
I think so. I think they're
yeah,
similar.
yeah. Radix sort just basically you did multiple bucket sorting order. That's what it is for radix sort.
Okay, cool.
It will probably matter that it's stable because otherwise.
And also actually, I think you only need to do 8. You only need to do 10 because the first two
but like
digits is
these are one for every digit, no one for like as in 0
Oh yeah,
to 9.
yeah.
Yeah.
Sorry.
But we only need to execute it 8 times. Yeah.
Also, strings isn't really a thing.
Oh
It
yeah,
should be string.
my bad, made a typo. Okay, and then we can say, oh, what about a variable name? So now we can say buckets I equals new array list. Okay, so now we have a list of array lists of strings. Gets confusing real quick, huh? So okay, what we do then, we go and say for string phone number in phone numbers. It doesn't say anything about space complexity, right? Oh, it doesn't. Poggers. So then we can say list string. It needs to return a list of string. Result is equal to new array list. So we can have this, and then for okay, so we have now the phone number, and that phone number will be, so let's say phone number is a, does Java use this? Okay, it does. 06 1 2 3 4 5 6 7 8. So imagine this is the phone number, right? We need to now be able to grab the, let's just say third digit for now. So let's say int, yeah, we can do int. Int digit equals to phone number dot substring,
You could also do char add.
Char add, does that work?
Yeah,
and
and
then it
then
should be
an
0,
index.
1, 2. And then we can do, then we convert that to a number by integer dot parse int. And then we can say bucket digit dot add phone number. And then we can go, we can say for list string bucket in bucket. For for string phone number in a bucket. So what we're doing here is we're going through every bucket and we're emptying it out into the result array. So we can say result.add phone number.
There's a mistake. It says you need to running on time.
Yeah.
Oh, yeah. Never mind.
Yeah, I think this like by definition runs in on time, or not by definition, but like it is proven that this runs in on time, right? Yeah. Okay, so we're going through. Yeah. Okay, I understand why it would look like this would not be on because it's going like it's like a two-dimensional list. But what's happening here is we're going through every phone number, we're storing it in a bucket. This all takes constant time. So what we're doing here is a constant times n. Here we're going through every bucket, and for every bucket we're taking out all the phone numbers. All the phone numbers in all the buckets is also just every every phone number in total. So all in all, these two for loops will also be n time, and the result.add is 01. So here we have something that runs in big O1 or big O of n. Here we have something with big O of n, and big O n plus big O n is equal to big O n. So this should all still run in big O n time. Oh yeah, I failed to create, so it should be a new array list string. Cannot create a generic array of array list string. Oh, and we cannot. It cannot change from. Okay, so what we have to do for the second error is we have to convert it to a string probably. Call it capital S. Let's see if that changes anything.
I mean, a char can be seen as an integer as well, so I don't think you need to parse int.
But if we take the char at and we take that as an int, then it probably is gonna take the char code, right?
Yeah, but maybe subtract something then.
That's gonna be like. Huh. I understand. It would work. That's true. However, I think it wouldn't be very elegant, and it would get confusing for people who don't quite understand the ASCII range.
Casting to a string would be easier then.
Yeah.
Maybe it works when you erase the generic tag in the array list.
Yeah, remove string from the.
Oh yeah, this one.
Array list part.
Yeah, that makes sense actually.
And if
No,
you
you
remove
even
the
remove
bracket,
also brackets.
Hmm?
Yeah.
Also the arrow brackets for the release, yeah.
After the arrow.
Just no, the peak one. Yeah,
there's multiple people
Just
talking.
do
One at a
release
time.
10.
Generic.
Okay, what were you saying there? I couldn't understand.
Just new array list 10. That's it. There's no brackets in the middle between the 10 and the
Oh yeah. I see. That makes sense. Cool. And are we literally not allowed to cast from char to string? Because this will. Yeah. Huh. And type expression array list needs check conversion to conform to list of string.
Just concatenate it with the empty string.
Can't just use an array list of characters.
I guess we could actually. I'm not sure.
Because right now you're making.
Oh, it's only a warning. I don't think it's an issue. It's only a warning. So.
It's only a warning.
value of.
Hey, we're getting 2 out of 2 poggers.
I mean, warnings are a problem for the spec test, but.
Well, they don't have to be.
No, I mean the warning says only type safety, so I doubt that would be a huge issue.
I mean, it says run truncated, so that means there's an error.
Yeah, that's because there's a warning.
Yeah. Okay, so.
Okay. Yeah.
Just add the less than greater than, like right after array list.
So here again, but we just had that issue. So let's see.
Uh,
Oh, you need to suppress the warning
no,
unchecked.
put a for the first for loop, maybe put the string in there, like bucket I equals new array list string.
I think you need to cast it when you create
Wait,
it.
so I have to say
no.
No.
I mean, I put it in the general VC. This should work. There might be a typo in it, but you can use this to just ignore the warning. I mean,
that's
what
always
they
the right
also-
solution.
That's what they also did in some of their weak
Yeah,
assignments.
just put a suppress warnings.
So
And
yeah.
look, guys, the warning's gone. And the spec doesn't work.
Well, no, they don't.
Well, yeah, but like most of them.
Well, if you consider that most of them.
Well, we're only sorting by one digit, so it makes sense.
Fair enough.
Okay, but now what? That's the question.
You gotta throw a null pointer exception at the beginning.
Wait, because you're only checking one. No, never mind.
Check whether the list is
every
null.
single digit from the end towards the beginning. Because that's radix sort.
Wait, what did you say?
We're only sorting on one of the digits. We have to sort like first
Yeah,
least.
yeah, we have to sort every single one of them, but that's like the next step. So we weren't there yet. This is bucket sort, but only if you do bucket sort multiple times does it become radix sort.
Yeah, yeah.
I might have found a solution. Use round brackets for the array list, and it might work.
Wait, which one? This one?
Yeah.
Yeah, but then if we do this, then it creates a new array list.
Just use round brackets. Try it.
I think like this.
No, instead of the square brackets.
Instead of the square brackets. But now it will.
Yeah, and you need
No,
also the
I think
string.
that creates an
No,
array
because
list
you're calling it as
with
array. No.
Yeah.
It has to be square brackets.
Yeah,
okay.
no, that doesn't work. We'll figure it out as we go.
The best solution would probably be to just make it an array list instead of a list. At the
Just have
start.
an array list or array list. It will work.
No, just instead of list, say array list as the type.
This one.
Yeah, that would
Oh,
probably
that
get
actually
rid of
makes sense as well. Oh yeah, we can do that for that, but not for this one because. Yeah, okay.
You could still.
Not really, because it needs to be type list string, and then we
Yeah,
have
but
a
Java will
different...
figure that out once returning.
Okay. What happens if I remove this now? Does it still work? No.
It still gets angry. Oh, no, it's just because you don't have the diamond in there. That's why it's angry. Because it doesn't know what type the array list is going to be.
So now I should say it like this. Sorry that we're
Yeah,
like
or just
working on
remove the
debugging
string
an
because
error.
that's not necessary.
Cannot create a generic array list of it.
It's being stupid.
Okay. You know what? Fuck it. This is not what the assignment is
Unchecked.
about.
Also, for the null check, you need to throw a null pointer exception.
Oh yeah, instead of returning null. Thank you. And it should be throw new null pointer exception.
By the way, you still have the diamond at the array list. It's going to error on that apparently.
Cool. 2 out of 2. Now what's vector? 27 out of 100. Boggers. Okay, so now we sort by char at 2. But now we have to sort each of the buckets individually, right? Let's have a look. Okay, so this is bucket sort, but we want... Okay, let's see. Oh. Isn't there like... Let's say radix sort? Okay. I see. Okay, I see. So because we're now sorting on only the second character. Yeah. So now we actually have to think. We actually do have to think about what our buckets are, because if it is stable, we don't need to create any more objects, and we can just loop through and do this part like 10 times, and that's it. But then with different charats. However, if it's not stable, then that doesn't work.
And also it's LSE, so you have to sort from right to left. Instead from so you have to like actually start from the last digits. Because it's the least significant digit, so it's the rightest one, and then move towards the left.
So you start at 9, not at 2.
Yeah.
Wait, should it be?
Yeah, it says.
Yeah, it's
LSD. Important. If you do not actually implement LSD radix sort, your grade will be set to 1.
Yeah, okay.
Which
yeah,
means
okay.
you-
I guess I was looking at this example, but I guess you can't really figure out too
Which
much
means
from that.
you technically, you don't need the substring thing, do you? Because you can just stop after you've sorted all the ones that are different.
What do you mean?
Can't you just once you sorted all the ones that are? Oh wait, you still need substring. Never mind.
Okay. About the stable property. Okay, so the thing is, I'm not exactly sure what here they say sequence, but I'm not sure what type of thing we have to do. I guess we can always use array list, but then the question is here: do we loop through this like this or the other way around if we want to keep it stable? I think like this should be fine. So then we can just do let's see. So every time we want to empty our result array and then refill our result array. That would be a good way of doing it. Because we need to iteratively execute this code like 9 times. Okay, so let's do for. First of all, let's just do indeed for int I0 I less than 10 I plus plus. And then instead of doing phone number here, we do result, and we can all yeah, okay. I'm not sure if they're exactly fine with us changing the phone numbers list. Adding everything would not make it less than it's really a tough choice. I think I'm just gonna do it like this, yeah. Phone numbers, because otherwise it might start complaining about my time complexity. So we go through phone numbers. I kind of want to remove the entry from the list then, but that's not possible with this notation. So unfortunately, I guess that we're gonna have to go for indexes. So int j is 0, j less than phone numbers dot length. Can we use dot length? It is an array list. Is that like dot size? J plus plus. So j is the index within the list of phone numbers. So then we can say phone number. Yep. Thank you for the comment, Jix. I already saw that. I got a message saying that we don't have to check the 0, 6 and that they will always be the same. Okay, so we can say phone number is equal to phone numbers j. And can we then say phone number or it's an array list, so it's dot get. But if I do phone number dot
You didn't initialize phone number.
yeah, I did initialize. I didn't declare. So this will be a string. What are the let me see if I can find array list real quick. I want to know if there's a is there like a remove first or something like that?
You shouldn't remove an entry whilst iterating over the list, though.
You need to remove from the first index. There's no remove first.
I see. Well, I mean, we can do remove with the index, and it will return the entry.
You should either iterate
Just use
over it
get.
using an iterator. You shouldn't remove an entry whilst iterating over the list.
Well, I'm not iterating anymore. Now I'm just going through like
yeah,
this.
But you're still using the size, so you need to either go backwards through the list, or you need to make a variable which stores the size before entering the loop.
Oh, that's a good one. Yeah.
You could also use an iterator.
But if I use an iterator, I'm unable to remove them from the array as I go, right?
I mean, you can remove it from the iterator, right?
But does that create a new iterator? Because I want to remove it from the original array. When I'm done, I want phone numbers to be empty because it needs to be filled up again afterwards.
Isn't the array list phone numbers that we're changing the one that is used in the test to compare again? So if we make an empty, make it empty, the test will fail.
Oh,
no, they will check. They will make an answer and they will check with that. So there will be a separate array list. Never mind.
Yeah, it's separate.
So we okay, yeah.
Can't you just like return a result array list?
Yeah, we do. Well,
then why do you want to empty your original array list?
Well, I mean, what I did first is I had an result array list, but I changed that because if we want to do bucket sort, we have to go over like the same list 10 times, and then first I would have to get everything out of phone numbers into results. So I would either before or after the bucket sort have to move stuff from the phone numbers array into results, or yeah.
I mean, it will stay O1, ON.
Yeah, it is still ON. That's true. But we just want to do that. It doesn't matter too much. Whatever. We can do that. Result is new array list, and then we can just say for phone string phone number in phone numbers result.add phone number. Okay, then I can say int size, or let's say int list size is result.size, and I can say for I less than list. Oh, I said list. Should have been list size. Okay, so now we empty out our list by removing the first entry. I'm not sure if this should be first entry or the G8. No.
It should probably also be a result instead of phone number.
Oh yeah. Yeah, and then we add it to the buckets, and then after this, our result array should be empty, and then we fill it up again here. And then we empty it, and then we fill it up again here. And then we empty it, and then we fill it up again here, and we do that 10 times. Or well, in this case, it should be from I starts at 2 and goes to 9 because.
Yeah. You also probably want to empty out your buckets.
Oh yeah, because we don't do that here now, right?
Yeah.
Why aren't we using queues, but are we using array list?
I didn't know which one of the two to use. I'm gonna be honest. Should we use should we use queues to make it stable? I knew for a fact that one of them would make it stable, but
queues for sure makes it stable because it's first in, first out. So the ones that are
then we'll do queues.
stay the same.
So we will make.
You can make this work. You can make an array list work as a queue.
Yeah, okay, that's fair. If we just only pick 2, remove the last one. That's whatever. Reassign phone numbers to new array list string. This way you do not have to delete whenever you parse an element. Oh, this is ON squared because when you remove at the first entry, it will have to shift everything. Huh. But I mean, I
Queue
guess
time.
Hmm?
Queue time.
Yeah.
Because linked list doesn't have that problem, right? No, it doesn't.
Yeah, that's fair.
What if you make the entire list backwards when you make it? Then you can move from the end.
It's removing from the end 01. Okay. If
I would
is...
say why not just use linked lists?
Yeah, that's fair. So we will make result a linked list. And of course give it a queue of string. So we have result dot. I think we can just add and remove with a list. So okay,
It
then we
would be
empty
remove
it out.
first or something, right?
Yeah, but I think remove first and remove are synonymous here.
Oh yeah, because it's actually a queue. Yeah, never mind.
Yeah. Okay, then we sort it by the digit. This shouldn't work probably. There we go. Cannot. Oh yeah, and then we have to empty it out from a queue into a list again. For string.
Couldn't you just cast it?
Can we? Can we do that?
It's technically a linked list.
Oh god.
Like, technically that would be kind of valid.
Let's
Not
see
sure
if
if Java's going to be happy about it, but...
No, cannot convert.
It seems to hate you. Okay.
And we already have a suppressed warning. That's the worst thing. For
Well, not on this, but...
well,
This is also a warning, not
Yeah,
an
there's
error.
actually a warning. You could suppress this warning too.
No. While not result is empty. Return array dot add result dot remove. And then we say list of type string result array is new array list. This
You
code is
have
a
to
lot.
rename the adding method that adds the not method in the loop. You have to rename it again.
Let's see which one.
The result array.
Yeah, you did it while I was saying.
Yeah, you did it right already. How long did I make this? Oh my god.
Okay, this is good. This is good. This like shows us what is going on because we're not emptying the buckets yet. Yeah, we're not emptying the buckets yet. Okay, that makes sense.
Didn't I say this?
So
and then we kind of forgot.
Actually, because it's like because a bucket is a queue, right?
The bucket is a
we
list.
can still just use is empty. So we can say bucket while not bucket dot is empty. Like I would think I'm doing this with a for loop, but this makes so much more sense. So then we can say result dot add bucket dot remove.
I mean, or the other thing I'm thinking is that you actually keep the for loop and you just keep the bucket dot clear in the end.
You are
maybe.
lagging
That
like
works.
fuck. I don't understand a single thing what you're saying. What are you saying?
Oh shit.
Okay, I think it's good again. The method remove.
Yeah, you need to use an index or an object.
So let's see. That will either be 0 or the length of the list. Oh. Aw.
I mean, you could also just use an make an empty array list and then set every array list. No, then you all have to do the same array list. Yeah. This is why queues are much nicer than array lists for this purpose.
But, So let's see. We add at the end. So we also want to remove at the end. So therefore we have to remove at, and let's see. So realistically speaking, getting the size of an array list would be, oh, that's not in here. Getting the size of an array list would be big O of 1, right?
I think so, yeah, because it's just a known variable.
Okay, then this array out of bounds exception, index 1, size 1.
-1.
God damn it, off by 1 error, I swear to God. Okay, spec test.
Spec test?
Damn it.
No.
Okay, time to write your own test. So if we have 06, 1, 2, 3. 1, 2, 3, 4, 0, 0, 0, 0. And then we have another number.
You can also just check if it's actually a phone number you're giving with the amount of characters and that they're all digits. I can already see them making at least one spec test contain non-phone numbers.
Not really, because they say we can assume this.
Oh no, that's fine. That's fine.
Yeah. So this is. Let's see. So if we sort it by LSD, or let's actually say no test. Just do that with zeros because that will make it a lot more like sensible. No. Says 1, 2, 3, 4, 5, 6, 7, 8. Remember when I said it would take less than an hour? Ha, good times. I didn't see this exercise yet.
We don't know what question 4 is.
Exactly. So if we have 3, 2, 1, 4, then with LSD sort, this should become 1. Oh. 1, 2, 3, 4, right? Do we want to sort them ascendingly or descendingly?
We'll see.
The test they wrote as ascending.
Non-descending order, so it should be ascending, like this, yeah. So save your tests. Oh yeah, test reverse too. It's not a test reverse, I shouldn't be calling it test reverse. Fuck, it works! Damn it! Okay, but now we can check that if we do it like this... oh, actually I should create a new test for this. So this test works. But we care about keeping the previously sorted digits. So if we have like 3, 1 and 3, 3 and like 4, 1 and then 4, 3, in which order should they appear? The current one, right?
Yeah.
Yeah. Yeah, then I shouldn't feed it with the already current order because then we don't know how well it works. So let's do it like this. Copy this. Paste this and get this one out of here. Into here. So this should work. It probably doesn't. Because I can't think other... There we go. So what did our thing give? 4, 1, 4, 3, 3, 3, 3, 1?
Yeah, that's wrong.
Hmm?
That's just
That's
weird.
wrong.
Yeah, but now it's not sorted in any way. Not an MSD, not an LSD.
Oh no, it is sorted. It's sorted on the first digit, which is all zeros.
Yeah, but Oh well, first
No,
of all,
but
we have to go from 9 to 2, right?
yeah.
So this should become like this.
That would probably help a lot. Or just make everything fail.
Or not.
Oh, I starts at 9. If it's bigger than 2, then subtract by 2. Bucket. Oh. I changed the wrong variable. I should have changed it here. So I starts at 10. It needs to be bigger than 2. Bigger than... I starts at 9 and it needs to be bigger than or equal to 2. Right? Because it starts at 9, 9, 8, 7, 6, 5, 4, 3, 2.
Add another minus though.
Hmm?
Add another minus.
Oh yeah, I forgot that. Okay, so this should help. And just like... Okay, good. Well, not good, but good.
Better.
So now it's what was 3, 1, 3, 3, 4, 3, 4, 1. What's the order we input them in? 3, 3, 3, 1, 4, 1, 4, 4, 3. So it's... Oh, and also we now sort them the other way around. That's also...
It's probably not stable then.
No. Huh. Well, this is good because I would have fucked this up on an exam, so it's good that we're training this now.
I mean, just an idea, but what if we use queues?
Didn't we start using queues already?
I mean, you can change it,
We
but,
used a queue over here, but we didn't use a queue for the buckets yet.
Let's just put a queue there. It's
Yeah. Oh, and this should be new linked list, and bucket should be a list of queues.
There's actually a Python solution available for this exact exercise.
A what?
A Python.
Yeah.
Yeah, we want to figure it out ourselves, I
Yeah,
guess. Because
like,
we need to do this on
how
the
many
exam
hours
as well.
do we have?
Like, we have 2 more hours to fix this one sorting algorithm, I think.
Exactly.
Oh no, wait, there's another exercise after this.
Yeah, we have like 2 exercises, but we've got like, what is it, 2 more hours?
Yeah, so we have like 1 hour per exercise, I guess.
Yeah.
Or technically you've spent half an hour on this, so like, still more time.
Yeah. It shouldn't be too bad. I think our code should still run.
No, because you forgot to change the array list.
Um.
Or the array of array lists.
So this should be linked lists.
The array list array.
Cannot convert. Oh yeah, and then here we have to say that bucket is a queue.
Then the remove doesn't take an argument anymore.
The method add in the type is not applicable for the argument boolean. Oh.
Yeah, you just remove with a thing.
So then this just is remove. Oh. Wait, you're fucking kidding.
Oh.
You're fucking kidding.
Queues always solve the problem.
You're fucking kidding.
So that's why they named it. So that's why they named that website Q.
Oh my god. Okay, guys. Oh god, I'm baiting
Just
in
always
the
use
dopamine.
queues. It'll fix everything.
Yeah,
Good
for
to know.
LSD it makes sense. I don't understand why it wouldn't work otherwise, but I guess it's something to do blah blah stability blah blah.
Q game.
Okay, holy shit. Okay, that's done.
You can probably make it work with array lists, but
Yeah, you probably
just
can,
don't.
but I'm just not smart enough for it.
You can make an array list work as a queue, and then it's the same thing.
It would work if you removed elements from the beginning, because you were removing elements from the end.
I see.
It would work otherwise.
Yeah, that makes sense.
Anyways, so we have to create a hash table. Poggers, bro. I mean, this actually seemed pretty. Okay. So we have
This
a
is
hash.
literally an exercise from the implementation exercises.
I think it is, but we'll see. So we have an int capacity, and we have a list of entries called table, or a list of, a list of entries. But you were not allowed to use any other data structure than the given ones. Okay. But what is that entry thing? Oh, an entry is just a key value pair. Oh, I see. Yeah, I forgot. I confused hash table and something else. Okay, that's good to know. It's not good, but it's good to know. Okay. Cool. So this will create if the input capacity is invalid, does that mean 0 or less than 1? Let's have a look. If capacity is less than 0 or less than 1, throw new illegal argument exception. Okay. Otherwise, it will create this dot entry equals new.
I'm pretty sure you mean this dot table.
Yeah, sorry. This dot table is new entry capacity, and this dot capacity equals capacity. Capacity doesn't look like a fucking word to me anymore, man.
No, it really doesn't.
Yeah, we barely even started. Oh god. Okay. I really do not feel like doing this, so let's do this one instead. Okay, so we have remove, get. Okay, wow. Okay, we only need 2 more functions. That's actually. Wait, we have this, put, get, and remove. Okay. There's something I do not quite understand with hash tables though. Maybe one of you guys can clear this up. So if we use linear probing, right? That means that if we put something in at key 7, but it's already like key 7 is already taken, that means it's now in key 8, right?
Yeah, exactly.
Yeah, but that means that if we now retrieve something from key 7, that there'll be a different value.
So then you start searching for the actual value that you for the key.
Yeah, you don't search for what the key is in the
Yeah, I
hash
see.
table.
So if,
You search for what the key is before it is like more or less.
yeah, so you also store the key
encoded.
in. Okay, yeah, that makes sense.
Yeah, because that's in the entry.
No, actually, no, because you just give the value, right, and the value gets hashed. So once you start probing, you just look for equals to value.
Well, not really. You give a key and a value.
Oh, okay, a key and a value, but
yeah. So you check the entry, get the key, and compare them.
Yeah.
Yeah, I see. Okay, so what we do then is we have a this thing of capacity, and this thing takes capacity, right? Yeah, modulo capacity. That's good. So what we do then is we go to okay, put says int. I was wondering like what should we hash, but then I realized it doesn't matter as long as we deal with collisions, as we deal with other stuff. It shouldn't be an issue.
Pretty sure you could just use the hash code method of the string.
Yeah, they have like a hash function here.
Oh,
it says string key. Okay, so we need to hash a key. Okay, so we say int index is hash code. Is that the no? It's just hash.
It's just hash.
So we say hash key while index or while table index is not null. Or let's do table index modulo this dot capacity, because linear probing wraps around, right? Like if it can be stored at the end of the bucket, it will go back to the front.
It does, yes.
Yep. Okay, that's good. So then we can use this, and then we can say index plus plus. So if this eventually reached there, or let's say index equals index modulo this dot index plus 1 modulo this dot capacity. That way, when index gets too big, it will wrap around. So then we don't need this part anymore. So if it's like if index is equal to the capacity currently, then it gets added by 1. It will overflow, but then it gets modulo down, and then we get back at the start. So that means now we know for a fact that index is full.
By the way, check if the hash returns it mod the capacity or not.
Yeah, it does. I've already seen that. Either this or we or the table is already full. We don't have a is full, right? No. Ooh, actually, so there's this defunct thing. That's
Yeah,
like
that's
when I
for when you remove stuff.
Yeah, but should all entries by default be defunct?
No, our entries should not be defunct. They should only be defunct when, when you remove a particular entry, because when you remove it, you still want, if you did linear probing before, you still want to be able to find the element that you did linear probing on. So therefore, you know that you need to search forward if you find a defunct node.
I see, but then we cannot just use this because table index would not be null if it's a defunct value.
Well, table index. Now we are looking for whether table index is null, and we can do that. That's fine, because the entry at the table contains null values, but the entry itself is not null yet.
Exactly. So we also have to check if table index dot So that means we will have an entry with a key that is null. And yeah, that's just really real basic stuff. So now we can just say either this or get key. Is it get key? It's get key. So either the thing is null or the get key is null, because that will mean that it's a defunct value and we can use it again. I really hope our exam will be just like this one, because we still have like 2.5 hours. Or no, yeah, 2 full hours left.
Yeah.
Okay, so now we know that the index is a good one. Then we can say, or let's just say real quick, int original index equals index. Because that way we can say if index is equal to original index, we can return false. This will mean that there's no more space left in the table, because then we will have wrapped around the entire table with linear probing and we will not have found a spot. Also, if key is null, return false. I'm doing this because they say here return false if the key is null or the table is full. So this is all the edge cases done. So now we can say table index equals new entry key value, return true.
I think there are still some typo on line 39.
That could very well be. I
see
forgot
only
a
one
closing
opening
bracket.
Yeah.
So now, if either one of these things is true, so either we have a null node or a defunct node, then this thing will become false and we will go on with our life. And if it's not, then we will increment, remove, and check if we're back at the start. Okay, the put function seems fine now. Returns null if the key is null. If key. I really enjoy that they put the edge cases in the comments. Like when we should return null, when we should do certain stuff, because that just like really helps. Because otherwise you're just guessing it and figuring it out yourself, which is kind of annoying.
But like, why would they help you out? Fuck you.
That's true. That's true.
Goodbye.
That's true. Okay. Let's see. If key is null, return null. And then otherwise we will say if. Okay, so we will say int index equals hash key. So this is the key that the hash that we have gotten before, and then we can say while table at the index is not, or okay, so we want to stop it if either it is null or it is the correct value. So it's basically this idea, but then instead of table.getKey is null, we have to check if table.getKey is equal to.
You can also do it with if statement, right? Like what you did in the in the thing above, where you do index is original index. You could do the same.
That's true. So if it is not null, if it is I'm not sure it would work, but it's I kind of want to see if this works as well. So if it is not null, so okay, so if it is null, we just increase capacity gone.
You know.
Actually, we don't even have to check. Oh wait, we do. I see. Because if we try to get a key that wasn't ever like done, then we do have to check if it's null. And if it's not null, then we can check. Wait, no, if this is, huh? I want to make use of the double equal sign thing here, but or the double negation. So if it's null, then it doesn't have to check the right one. Okay, so yeah, if it is null, or the key is not what we're looking for. Okay, I think this should work. So let's see. In my head, if we have a table with at the index it's null, then it will trigger this one, not even look at this one, go to the next one, and we can again have indeed like an int original index.
I think this makes sense, right? So you need to keep searching while the entry is not null. If it is null, you need to stop.
Not really. I don't think. If the index is null, that just means that you're at a spot that was not null. And then we can just like increase the, then we can just go on to the next one. And if that is null, then,
I think
No, I
for
don't
getting
think
easier wild
No, we
statements.
could stop because then we know that for sure it's not going to be there in that list.
Oh yeah, because the get key would be null if it's like. Okay, so what I was worried about is that if it was inserted in another spot, but then it would not be. Huh.
Yeah,
But
that's
what if we get a key that is whose hash code has never been evaluated yet? Then we get a null pointer exception.
That's why I think we can compare the values directly.
Hmm?
I think we could compare the values directly.
Yeah, but then we wouldn't like. Yeah, theoretically we could just say, okay, if table index dot get key is key, and then just return table index dot get value. But there's multiple things we need to consider here. This would work if we had, first of all, no linear probing, and second of all, no what's it called? Not has to deal with the fact that no values can exist in our table.
You can add a check right before that, right? So just if it's null, return null, because you know
Yeah,
it won't be anything else in the table.
But if
or maybe it is. Oh yeah, it would be. Yeah.
Yeah. So I think we'll have to.
Really don't get. I think you're just misinterpreting things because if you have in the while loop table index is not equals to null, then you know the thing is not null. And then in the while loop, you just have an if the current thing has the key you're searching for, then you return it. If it's not, then you continue until you're either sure it's not in it or.
I see.
Yeah.
I see what you mean. I'll try that. So if this is the case, then return table index dot get value, and otherwise
You have to change the return type for the other if statement. If index.
Oh yeah, and this would
index be not false.
But what would it do then?
It's in the description, but you need to scroll right.
Else no. Okay, cool. So this should be just return no. Okay.
And one more thing for the put method, it actually requires you override if there is like the same key already present.
Is that given?
On the second note on the left.
Yeah, this one. An entry is added successfully if the key is not null, regardless of whether an entry with the key already existed. So we don't have to worry about duplicate values. That's cool. Okay, so we have get, we have put.
Get also needs to return no if the while terminates.
But the while never terminates, right?
It does if entry is no.
Hmm?
It does if the.
Oh wait.
That thing needs to be negated, and then it terminates when it's null, and then you also just return null.
But if it's null, should we terminate?
Yeah, we should, because the linear probing only exists until there's a null element. That's why you have to do the defunct thing.
That's true. So this should.
But I think the problem is, say you add two things with the same hash.
Yep.
And you remove the first element, then the element at the original hash will be null, but still the next entry in the table will be
No, it will be defunct instead of null.
Yeah, that's what I mean. But I mean so it will be defunct, and then the next the next element will be the one you might be looking for.
Yeah, I think this accounts for that. Because it only returns if the actual .get key equals the key.
Yeah, this should be fine.
Okay, let's go with remove now. And then look at the edge cases. Remove an entry associated with this key from the hash table. Return false if the key is null. Otherwise, okay. So return false if the key is null. If key is null, return false. Let me get rid of this to-do thing. I always keep my to-dos here. I don't know why. Okay. So now, the entry associated with the key. Well, then we just do the do what we have here as well. Or I guess it's, yeah, it could be a get, but then instead of returning, we just say defunct. Okay. And here instead of null, we should say false again. And here we should say return false. Because the only way it's true if this thing is equal, if we find something that has the same key and it is defunct, then we should return true here. So this should work. Poggers. Original index was not initialized. Oh, yeah, okay. Or is index. And do I do that here as well? Yeah, I do. And then we also get, oh! Ooh! Alright. If put receives a key that's already in the hash table, the method should replace the value of the entry with that key. That's probably the thing that's happening here. We can actually create a test for that real quick. So we can create a hash table. Okay, so now we can do solution hash table tab is new solution hash table 1, or let's do 3. So now we can say assert true with lowercase a. So we will have a key of, or a tab, or we'll put in our table a key of hello, and then a value of world. Then we will put in our table a key of hello and a value of YouTube, and then the get should equal. We're doing something wrong. I already know what's wrong, but let's do this anyways. Assert, and this should be assert not equal, or assert equals. And legal argument 2. Score 2 out of 2. Oh, I should have put at test up front. Expected world, but was YouTube. Oh, I put these two the other way around. So this is one of the issues. Another issue I'm having is that we are comparing strings with equal signs. So here we do .get key is equal to key, but it should .equals key. Let's actually do key.equals that. Because we don't know if the thing is null, but we have already checked if key.equals. If key equals null. Okay, so this should work. And also... Okay. I fucked up something somewhere. If key.equals table.get .index index.get key. This should work. Why is it not working? Line 68, because I'm looking at the wrong one. There we go. It's still a legal argument exception, but it is something that maybe a hidden spec test would have got or something. I don't know. I tell that to myself to make me feel good. This is the if put received a key that's already in the hash table, it should replace the value of the entry with that key. So where are we with put? Okay, so here, if wait, let me actually invert this using that one law, so it's more readable than this. So if the table index is null and is not null and the get key is not null. Ah.
And also, maybe you can put after the return false, first return false, you can put a remove key to make sure that if, for example, if the key is already present, so it would be removed and then overwritten anyway.
Wait here.
No, at the top, if key equals null, the one after the first if.
This one. Or this one.
No. Yeah, the top one. Yeah.
Yeah.
After the if, I mean after the if statement.
Yeah.
Remove key. Just run the remove statement just to remove the duplicate if it's already present. Not within the bracket, but like outside the.
Oh, here.
Yeah. Remove key.
Ooh, I see what you're doing. Oh, you sneaky. Okay. It gives an error, but that's because.
Not remove key. It's remove.
Oh, it's
just
not
remove key. Yeah.
Yeah. So, oh, I see. So you're using our own methods against us.
Yeah.
There we go. That is the first. I think that should be all of them actually. Submit. So the question is, does it give us a grade? It doesn't. But we've gotten like 100 points for everything, and like, so if we go to, we are allowed to discuss our midterm. Yeah, we got our results for our midterms.
It was formative as well, so.
Yeah, okay, that's true. So if we go to my oh, that's the analysis. If we go to my implementation midterm, I had quite a good grade. If you guys want, we can go over this. I'm down for that. Either that, or we can do another one, or we can stop here. Up to you guys.
Well, so maybe go for another one and then come back to midterm maybe.
Another one, I think.
Okay, cool. Let's do. First of all, let's stop the split here. 1 hour 22 minutes. That's half of the time it would take for that like we actually have. That's like impressive.
Good RNG.
Yeah, dude, we're like dreaming here.
To be honest, I rather don't dream about ADS, but
Yeah.
Yeah.
I mean, my dream is just to be able to finish one, honestly.
Yeah, man.
Like finishing with just 100 out of 100 on all spec tests is already impossible.
I mean, we've done it a few times just now.
Yeah, but I haven't.
Yeah, okay.
I think for me the biggest thing is when I start doing it and then I fuck it up so bad I can't read my. And it's better if I just start again.
Yeah, it depends. Like, sometimes you indeed like. I have started again before for implementation questions. Like that has happened to me before, but I think all in all, especially if you have this much time left, it's not too big of an issue. Guys, let's see if we can do this one in like in less than 1 hour and 40 minutes, because that will mean that we have that we will have done two of them in a time that we could have done one. This is a practice computer exam. Practice exam and term. Why is it saying that? Huh? Okay. Whatever. Okay, let's start. Oh, yeah, the button for starting the splits also reverses this. Whatever. Okay. You need to implement a multi-map. Wow, okay, it's really good that we were just doing that one. Okay. So when we create a multi-map, it creates a new multi-map. So then we just say map equals new hash map of integers to a list of integers. Either that or we can just straight up leave this out. I'm not sure if that's allowed. Oh yeah, should return 0, return true. I'm just putting these here so I can like test my code while we're going. Return new, or return null actually works. And this should be return true. The field, okay, yeah. So it's only a warning, so that means it does work. Okay, cool. I guessed the type correctly in one go. Let's go. Okay, size. Let's actually open up a hash map here. See what the things are we can work with. So let's see. This thing does not take any arguments. Returns the num. Okay, that's good. Okay, yeah. So this thing does not take any arguments, so we do not have a set size. We just have to check how many pairs there are. So I guess we can actually do this. So we can. Does it actually have a size function or not? Oh, hey, dude, we're gaming. We can just say return map.size.
No, one entry can contain multiple.
Yeah, not gonna be this easy.
I see. Oh yeah. Okay, and it will be a list of integers. So for every like key we have, we should go through all the values and count them up. That's good. That's all right. So we
Or
can
just
say.
count up the sizes of the list. Or just count the size. You don't need to go through the.
Yeah, I would just get value set, or do map.value set.
Does that exist?
Or is it it's values actually? Dot values.
Where is that?
Bottom.
Oh, this
Primitive
one.
attributes, so you can just
Okay.
keep track of the size.
So we can just say in total is 0 for list integer current list in map.values total plus this current list.size return total. Woo! That's probably because we don't have any of the other things, but this is
Yeah,
good
they
for
can't
now.
really put anything in, so their
Exactly.
size is not gonna match.
Well, I mean that's pretty easy. Then we can just say map.values.size is 0. I mean, like honestly, we are just creating a helper class for a function that already exists, which is always really nice because they already have most of the stuff you need. It just like you need to know how to use it, and for that you can have their Java doc, which is cool. Okay, so we can say if do we have a hash code function?
We don't need a hash.
Oh wait, we
Key
already
is
have
just
a hash
an
map.
integer.
So
Yeah.
let's see. So we can do dot contains, right? Let's see. Contains key and contains value.
You can also use get.
Holy shit! Okay.
What might be easier is get our default. Because you wanna get the list at the key or create a new list.
I'm just gonna use contain, but it is a good suggestion. But I want to keep it like relatively not too complicated. So I'm just gonna use like most of the basic functions within the thing. So let's see. So if what was it again? Contains. If map.contains key then this is already a list, and we can just say map.get. Let's see, is it get value?
Just get.
Oh yeah, get object key. Map.get key dot add value. Then if it doesn't contain the key yet, then we can say map dot add. I'm not sure if that's the thing. Let's have a look. Probably put, yeah. Yeah, put key value. Put key. And then it should not be key comma value. It should be new array list. Or let's actually do that outside here real quick. List of integer current list equals new array list. Current list dot put value, and we add current list. Because again, we're not creating a list of that maps integers to integers. We're creating or a map that maps integers to integers. We're creating a map that maps integers to list of integers. Yeah. Okay. So then this should work. Cool. And then we can do get return all values in the multi-map for the given key. If the key is not in the map, return an empty list. Okay, then we can say if map.contains key, return map.getKey, else return new array list. I wish all of the functions went as well as this one. Oh, cancel. Oh fuck, I fucked up. Can I undo my split? Whatever. Keep in mind we have 7 minutes more than what's there, but I fucked up and clicked the wrong button, and I CBA to change it. Okay. So we have this function. If map.contains key, or actually let's do if the map doesn't contain the key, then we return false, because you can return it if it doesn't contain it. If map.getKey contains, is that a function array list that contains? Yeah, right?
Yes.
Cool. If map getKey contains value, or if this is not the case, then we can return false. And if it is the case, then that means we have a key and the value is in there. So we can say map.getKey. However, do we say remove value, or do we say
yeah.
Yeah, but the value is an integer. Won't it see it as
Oh,
the
that's
index?
gonna confuse it. Yeah.
Do we have
That's
index
gonna
of?
mess with it.
Does array list.index of exist?
I think so. Yeah.
Let me have a look. Array list dot index of, yeah. So now we can say remove the object at the location map.getKey.index of value. Return true. This is not pretty. Method put it on the 5 for the type. Okay, line 48. Current list
dot add.
Oh, it's add, not put. What else do we have? Oh, forgot a punt comma, a semicolon. 1 out of 1. 63 out of 100. Damn it.
6 more.
Null checks.
Keys and values will never be null.
Oh, okay. Well, they're nice, I guess.
Yeah. But our test should already check everything. It does. That's so annoying. Let me add one more. So now it should say a third true.
Maybe there's something in the important notice on the left that you're not being like.
Okay, let's see. You are not allowed to use any auxiliary data structures beyond the map field that is already provided in the class template, and the list that are entries in the map or returned by the method directly. You are allowed to create additional methods and primary fields. So I think we are definitely abiding that. The only place where we create lists that are not, yeah. We only create array lists here and here.
And I also really don't have a way to check that with spec tests, I think.
Yeah, I don't think so.
That's just human.
Oh. So once this entry is, ooh, we don't check if. Okay, yeah. I get it. So now if we can say map.get key dot is empty. Because right now it has a key with an empty value.
Wait, but why would this even matter?
Is that allowed?
Because, well, it shouldn't be there, but shouldn't matter.
Well, let's get rid of it anyway. So
yeah,
can we remove this thing then? So
you can just do map.remove key.
Let's go.
Well, that works.
Let's go.
Wait, go back to is empty, by the way. In the thing. Yeah, you might want to use our own size method in there.
We don't have a size. Oh, we do.
We do.
I mean, this works as well because the only way it's empty, like this is by the way the reason why it wasn't working because we would have an
I guess
empty
it
area.
works, yeah.
But if it works, you know, why not? Okay. Index or ooh. Ooh. Okay. You need to implement the method indexor, which sorts the indices of the input array on its based on the hardware that's installed upon. No, based on its values in alphabetical order using the insertion sort algorithm. The values are string objects. Index sort should create and return a new array of integers containing the indices. But the thing is, how do we sort AB? Imagine we have this. Which one to go first? Do we get anything that's? I think it's just gonna ask us.
I think it's just one character, yeah. Why they didn't use a char array, I don't know, but
whatever. So we need to do insertion sort. Well, that's alright. We are allowed to use.
Well, no, it's just alphabetical order actually. So
then just the alphabetical order of the first character.
But it might be something.
Just
that
use
is
a
like
string
ABD.
compare.
But oh yeah, you could. But you're not allowed to use other data structures though.
No, but it's not data structure. It's a method of string. Compare to.
Oh yeah.
Okay, let's go here and go to week 6. It should be week 6, by the way. And we're gonna do insertion sort. So that's gonna be within this one. Fuck the readings. Whoever does readings. Videos. Insertion sort. Worst case ON squared. Let's go, boys.
We can make that ON cubed.
Dude, we can make it ON factorial.
No.
No, you monster.
Oh, can we please not do this?
I was gonna say O infinity, but that would technically be O1.
It depends.
Yes.
If it's O infinity, it will be O1, but if it's O n infinity, it will be O n squared because infinity is just a constant. There are a
What
lot
is
of mathematics
Yeah.
people being really mad at me for saying that.
N to the power of infinity.
That would be a really yeah. Okay. So
That would just be N.
we are not allowed to create auxiliary data structures, right? We are allowed. Yeah, we are allowed to use the Java library method for string comparison, so that's a good one. We are not allowed to use priority queue. So what we do then? Dude, holy shit.
You're allowed to use an like an int
An array of
integers.
Yeah. So we can say final like array of int final array equals new int of the length of rr dot is it size or length?
Length. Because arrays have length.
Yeah.
Other data or collections have a size method.
Collections, fancy ass. Okay, so we have an int final array of length of our normal array, and then we have to do insertion sort. So what do we do for insertion sort? I guess we just insert it at the place where it should be, right? The thing is, are they gonna bother with duplicate, like with duplicate tests?
Knowing them, they definitely will.
Ugh. But then we can't use index of.
Look at this. Oh wait, no, wait.
Your algorithm should return null. Wait. So, oh god. If r is null, return null. If r is r dot length is null, return new int null.
This is the second one you're doing now?
Yeah, because that's because of this one.
What?
If the list is empty, then it has to return an empty list as
No,
well.
no. I mean, like, is this your second implementation exam since you're
Oh
on
yeah,
9
yeah.
minutes? Nice.
Yeah, we finished the first one in 1 hour and 22 minutes.
Smooth.
Yeah, we were done. I was like, whoa. I mean, to be
I'm like,
fair, we do
whoa.
have a lot of people here. A lot of people.
Oh, the other
shit.
two implementation ones are actually kind of fun. The 3 and 4.
Ooh.
They're better than this.
Men speaking ahead already, huh? Okay, so method must return. Okay, let's see. Let's do return final array real quick just to make sure.
With the implementation tree
Yeah,
of this
2 out of 3.
exam, we already have done during practice weeks.
Hmm?
During like practice weeks, implementation tree was already between like the implementation practices.
Oh wow. Okay, well that's good for us. Die stoppen wij in het zakje, as we say in Dutch.
What?
Die stoppen wij in het zakje. It's basically a translation of we put that one in the bag, I guess.
Ah, yeah, we got it in the bag.
Yeah, practically. Okay, so now we have an array. So we have to use insertion sort. Let me see if there's like an explanation of insertion sort here. There we go. So, oh no, this is just insertion sort with a priority queue. I don't care about
I put a link in
Insertion sort is you just
general
find
voice channel
min.
channel where it's a link to a CS hub.
Yeah, but
that
we wouldn't be
explains
allowed
the
to use the
insertion
C at hub
sort.
both, so I'm gonna do it without it.
No, but insertion sort, you just take the minimum, isn't it? And then you insert it into the next one.
I mean,
It's,
yeah.
It's just you just find the minimum and then put it at the front.
Oh, that's now that you mention it like that, it's actually really easy.
Yeah.
And the best thing, it doesn't say anything about the thing, so we can just loop over the list as many times as we want.
Well, it's n log n. It should n log n if you do it correctly.
Yeah, if we do it correctly.
But we don't care about correctly.
We don't have
We care
to
about
n log n.
cubed.
As long as we use index sort, it shouldn't. Index sort, insertion sort. It shouldn't matter what time complexity our implementation of insertion sort is, as long as we have the same, like, quote unquote spirit. So we can say, while final array is
Wait,
not.
which
sorry, another.
fact exam is this under?
This is under 2000.
2019, 2021.
Yeah. No, 2020. Oh yeah, 2020A. I think. Okay, so while this is not true. Oh wait. Yeah, I can't use length for this.
Yeah, I'm on it.
Huh.
Why can't you use a length for it?
Because the length is always just equal to each other.
Yeah, fair enough.
Just use I.
Yeah, I guess I can do for loop for int I 0 I less than r length I plus plus. So now we have to get the smallest element. Then we can go to Java, and we can go to string, and we can go see if there's a string compare thing anywhere. So there should be a Java string clause here. SOAP, SQL, string writer, stroke, string joiner, string. String compare. Constructor. Okay, here. So there should be something with comparing here. Content equals compare to. Compares to strings lexicographically. Let's go, boys. Okay. Does it matter if we modify our original array? I don't think so. No, I don't think so.
Don't think so.
Okay, so we can have min or a string, or let's actually do int min index is equal to -1 while or for int j0 j less than r dot length j plus plus if Okay, I'm gonna do it like this. If I say if j is not null and j dot compare to, and then we will have there should be a default value because we want to
0.
get the minimum.
Or as the default value would be, I'm guess, sed.
Okay, so we have like a min index which is -1, but we want to compare it to. Well, actually, let's just say if min index is equal to -1, and we should also have a int or a string min character is equal to nothing. If min index is equal to -1, then we can say, okay, we're at the first element. And let's do also.
Why not just set it to the first element and
That's what
then?
we're doing. Yeah.
No, but just in the.
Yeah, but
string
the
min
way I'm
character.
going to be doing it is when we already have an element. I don't want it to be able to be the minimal element again, so I'm going to set that element to 0 or to null. That's the best way of, like, at least I think the best way of keeping track of which elements we already had. I mean, we can also check if our array contains, if like final array contains the index, but I'm not sure if that would be better or not. Let's do it this way, see if it works. So if the index has not changed yet and j is not null, then we're at the first usable element. So we can say min index is equal to j, and min character is equal to array j. Okay. What is this compared to thing? Let's have a look at that. Less than 0 if the string is lexicographically less than the string argument. So we want to have the minimal value. So we have to compare if this thing is less than 0.
But you don't want to, or you don't want to compare j because that's a value. You want to compare the array.
Array j.
Yeah.
Thank you. I'm so
No
used
problem.
to.
You probably also want that in the if statement, don't you?
Yep. And this one, so we want array j. Okay, that makes a lot more sense because, like, you can check if a number is null, but we have set that number. It's not gonna be null. So
Well, an integer can't be null, even.
yeah, exactly, because it's a primitive type. Okay. So this should work, and after this iteration, we should have the minimum length, minimum index. So what we can do now, we can say final array. Let's do int pointer is 0. Final array at the pointer is equal to min index.
Isn't what you're implementing right now selection sort?
Yeah, no.
Fuck.
We're supposed to implement insertion sort.
Yeah, I know we're supposed to implement insertion
Yeah,
sort,
but you're supposed to insert it.
No, I think you're
selection
selecting a
sort.
minimum index, I don't know, number. So I think it's the wrong one.
Motherfucker, I think you might be right.
Don't they work quite alike?
They do, but they are different things. Let's see, there's like a thing for sorting and selection, so we can see. Wait, where's the others? Where's the rest of my sorting?
It's under, I think it should be under the same where you find lists.
See sections 3.1.2. Hey, let's go. Okay. Hey, there we go.
There's our insertion sort. How useful.
How kind of them. Holy shit. Okay. So we're gonna put this to the right, this to the left. Get rid of this, get rid of that, get rid of this, get rid of this yee ass haircut. And zoom in a bit. Okay, so here we have our insert. Oh, that does not look pretty. Is there
Top
a
right,
way...
the arrows.
Ah! Okay. I don't want to kill my baby. So what I'm gonna do is I'm gonna comment this out. And see if we can use any part later. But yeah, we have... I'm actually gonna copy this line for line. Int n is data.length for int k is 1, k less than n k plus plus. String ger equal r k. Oh, we have data per length should be r.length. Int j is k. Their code is ugly. While j is bigger than 0 and data j min 1 is bigger than ger.
It should be a raging.
Oh yeah,
It's
I
okay,
keep yeah. I'm just like literally copying it one by one. I shouldn't, but whatever. Array j is equal to array j minus 1. J minus minus, and then we can say data or array j equals ger. But the thing is,
Instead of the array j minus 1 is bigger than ker, you probably want to use compare to instead.
Yeah. So array j pin 1 dot compare to ger, and then it has to be less than 0. However, this is just a normal insertion, like in place insertion sort.
It should be above 0.
Oh yeah, because ger has to be bigger than. Okay. However, this is just insertion sorting the normal way, and we don't want that. So let's first actually see if this works. I'm just gonna say return or for string s in our array return s, or system.out.println s. That way we can test if this works. So this should print ABCD. Yes. So then we return our final array. This should print ABCD. Okay, our insertion sort works. But now instead of this,
What you want to do is we want to put res of j is equal to the number.
And you put the same thing that you do with R, but you do it with int.
You can do something else. You can do is initialize final array with like the index of each character, and then when you swap the character, you also swap the numbers in the final array.
What?
So we're swapping
Oh
both
yeah,
C
that's
together.
actually kind of smart.
A D D D D. Oh.
No. Like when you're swapping, for example, in the while loop, when you're swapping J and J minus 1,
Yeah.
at the same time, like at first you initialize the final array like with each index of the character, and then when you're switching the array J, and then you just do final array J is equal to final array J minus 1.
Oh wait, yeah. So we're just swapping the indices as we go.
Yeah.
But you should. Did you initialize the final array with?
Nope.
Yeah.
We're gonna do that in a bit.
Alright.
So this should be K is the original one, so then we should set this to K as well. We don't change K, no we don't. Okay, cool. So then here we should also say for int I is 0, I less than r dot length I plus plus. Final array I is equal to I. Hey, 3 out of 3. Hey, 100 out of 100. Oh, 90 out of 100.
90. Fuck.
90.
Yeah, we don't need this anymore.
Some weird.
Null
some
checks?
weird cases.
No, my null check. There's 2 null
Oh,
checks.
there's a null
They
check.
won't-
Okay, never mind.
They won't work. How do I get it back out of like the big here?
The one on top, yeah.
Okay. Damn it, this should work. Fuck.
I think it's the fact that the original array shouldn't be changed.
Should it though?
Yeah, I got the spec test, but it was that. So, but I don't know how they expected us to do it without additional data structure.
I mean, you can just make a copy.
Yeah,
you're not allowed to.
I don't think that counts.
Oh yeah, you're not allowed. I mean, you can just copy manually. That also works.
Not really, because if you only create primitive types, then you would have to create infinitely many primitive types because they can ask you to do infinitely many. And without an array, that would be really messy.
You could just make another array and just copy the things in there, right?
That's not allowed, right?
Why not?
I mean, you could.
You could, but
You
it's
just-
not allowed.
No, I mean, you don't really use the copy method. Just use do another
But
for loop.
Just try it and see if those are the spec tests.
If that is really the spec test, then it's kind of
I
bugged.
don't know.
But I kind of doubt it. I'm gonna be honest.
Yeah, I doubt it as well, but.
Oh, it is, but.
Where was it? Wait, where was? Okay, under 312.
Okay, wait. So I'm gonna do this, and then so this shouldn't work then because we changed it. Oh, excuse me. So this shouldn't work then. Yeah. But is it even possible to do it without it? Maybe. Wait. Maybe we can go back from. No. Wait. the
Wait,
zone-
but you made a mistake. You did A B D C.
Yeah.
That's right.
Oh, that's a DBC. I see.
Oh, well.
Yeah, I didn't see it either. Yeah, but still. Expected B with what D.
Oh yeah.
Damn it. Is that?
I mean, we could give it a try at this point because it's only like 10 points. I mean, maybe it's like they don't want to change it. Maybe.
Is there a discussion on this? No. Is there?
I got it. I think I have it. Think I have an idea for what we
No.
can do.
What's up?
If you into the or
Actually,
No,
I'm gonna
never mind.
have a way to check real quick. So if I say let's see, you're not allowed to use any auxiliary data structure. So I'm just gonna say hash map or map.
Wait, would it? Would you
Wait, but
technically
they
like
can't
fail
check
if you
if
use the
you
hash
use
map?
auxiliary data structure.
Yeah, you would.
Yes.
In your
Fuck.
can they?
I did that. God damn it.
Mm-hmm.
Okay. So if I now get less than 90, that means they have a way to check. Oh, I'm so. Oh. Yeah. Okay, we can't.
You can still put the import there manually though.
Yeah. Okay. Import.
And they don't have a way to check that.
Java.util. Star.
Star.
Let's import everything. Okay, spec test less than. Okay, still 90. So now we can check that if we just create this array, and then add all the. Actually, I'm gonna do that in here real quick. So I can say final array I is I, and I can say test.add ri. Okay, and here I can say for string s in test, or actually let's then do for int I is 0, I less than r dot length I plus plus, and then we can say print ri, and then set ri to test dot get I. That way it should be back to its original state afterwards. Motherfuckers, how are we supposed to do that?
Just making a copy of the array.
Yeah, but we're not allowed to create any auxiliary data.
And what other method? If you use another method, then
The thing is data structures. Do they count?
I'm pretty sure arrays are allowed in this case.
I think array is
yeah, aren't
fine.
they primitive?
Yeah, but like they
arrays
say
are
data
technically
structures.
primitive.
So then they should.
Oh no.
I'm pretty sure you're just allowed to make a copy of the array and operate on that instead.
They're not primitive types.
String temp array. I'm gonna say, or let's say storage.
You can also do the .clone. That's
We're not allowed to use Java method library methods.
okay.
Ri. And here instead of test.get we say storage I. Save your test. Compilation's failure.
It's size.
Oh yeah.
Oh no, it's fine.
No, I literally just.
That's just yeah.
Yeah, no, the thing is smart. I'm just dumb. I do the same thing.
Actually,
again, don't I?
compile your code.
Oh,
yeah.
I did compile it. I just didn't save it.
Or save it, yeah.
Java util is never used. You know what? This is a W in my book, guys. Come on, we got 100. That's okay.
We are waiting for it to actually happen.
Yeah, no, I'm always really cocky. I say we have 100 before we actually have 100.
And then we get 90.
And this is implementation 3. We are allowed to use our own implementation, right? Because
yeah, we are.
You guys thinking
Are
what
you?
I'm thinking?
Yep.
I don't think you're
pull it
able
up.
to see it, though. Pretty sure WebLab stops you from looking at it.
I'm pretty sure you can, but I mean, like, who doesn't have it all in IntelliJ anyways, right?
Me.
Me.
I try to
Me.
make a point out of not using IntelliJ, so that in the case that I don't have access to IntelliJ, I don't have an issue. I'm gonna grab a drink real quick because I've been talking so much my throat is hurting.
IntelliJ is just useful for like methods.
Dude, my IntelliJ is like a database of all the solutions.
Yeah. For me, I just use it because it's easy to type. Like you just type a point and then you get a whole list of methods.
Yeah, but the thing is, I try to do it in IntelliJ so that in the actual exam, we're not allowed to use IntelliJ. If you're using IntelliJ,
We
that's
are,
another.
you are allowed to use IntelliJ.
Yeah, okay, fair. You are allowed. I think for me it just makes everything slower though, and I CBA.
Yeah, that's fair
You
enough.
just need to copy the solution, test, and library. That's all.
Yeah, but the thing is, sometimes you cannot. You don't have access to the library.
Yeah, yeah.
Sometimes it
They
says,
can
"Hey,
fuck
we're
you,
using
but-
a previous, or a good implementation of assignment 2," and then you're fucked.
Yeah, true.
My brother always works in IntelliJ, and like every time the assignment is like that, he's just like, "Oh fuck," because he can't copy it over. But
Yeah, true.
okay. We've already done this though, so I'm not really gonna bother. So implementation assignments, week 7. Hey. Okay. So was it there or was it here?
No, it was main matter.
It's color of the tree, right?
Yeah.
No.
Well, I guess you have to do it anyway.
Yeah, but that mean it didn't save anything, motherfucker. I did this. Also, a binary tree.
Do a revision history.
Oh, that could be true. Show revisions. Solution. Huh?
Did you ever do that? Are you sure
I
about
did
that?
it.
Cap.
I did. Look, it says January 11th. Ugh, whatever. Let's just do it then.
It's not even that hard.
It's not really. So, black, red. Black, red?
I think it's red.
Red, black, thank you.
Yeah, red, black.
Okay, so we have a tree, and what are the functions we can do? We have is black, is red, get left, get right, and get value. Poggers, bro. Then we can say if... Oh, I think actually we might have to do recursive stuff on this one. If tree dot...
That would make the most sense. You don't necessarily have to, but it makes a lot of sense.
Tree dot is black. Yeah, okay. If tree dot, if not tree dot is black, well then we know that it's not a tree, or it's not a red black tree because the head has to be false. Head has to root has to be black. Okay. Every external node is black. The children of a red node are black. All external nodes are the same black. Something I didn't understand. Yeah. Why would you use a red black tree over any other tree?
Looks cool.
Yeah, no fucking clue, honestly.
Yeah. Okay.
I guess it probably has some use.
Yeah, it probably does, but
I think I remember like insertions were faster or something like that, but I'm not 100%
It's
sure.
basically just another way to display binary AVL trees.
It says it uses O1 structural changes after an update.
Oh yeah. No. It's easier to restructure, I think,
yeah.
compared to an AVL tree.
Yeah, because in the AVL you have to like insert new values into nodes and like split nodes and stuff, and here you just have the one value per node.
Yeah, that's true. Whatever. Well, let's just work with it. So we have the root property done. The children of a red node are black, and all external. So these three are like really not that hard.
Yeah, and then there's the bottom one, which is annoying.
Yeah, this one is this one's hard. Let's it doesn't say we have any. Oh, we don't have. Okay, we're not allowed to create auxiliary data structures, but we are allowed to create primitive fields. Okay. So I think we could just do this all in a like beforehand, and then do a recursive thingy-majig for this. People are starting to lose interest. Nice.
Yeah.
But that's alright. We'll finish this exam and probably be done then. Every external node is black. Children of a red node are black. All external nodes the same black depth defined by the number of proper ancestors that are black. Why does what's the difference between a proper ancestor and just an ancestor?
Good question.
Yeah.
Oh, probably that it's a direct ancestor. No, that
That's just a parent. They just call that a parent.
Yeah.
Yeah.
Isn't the proper ancestor like one that does not include itself?
That could be.
Yeah, that makes sense.
Yes. Number of proper ancestors is all the ones directly above it. So, for example, for the one under the 3, it's to the one to the left of the 3. That's 3, 5, 12. So they
Yeah.
all have 3 proper ancestors in this case.
I see. Okay, let's get going. So, it is kind of annoying that we're not allowed to create auxiliary data structures, since if I recall correctly, when I did this one myself, I used an atomic Boolean value in the tail recursion. That way I could change that. But let's just see how far we get.
Well, Boolean is a primitive.
Yeah, but an atomic Boolean isn't. And the thing is, I need something to be not primitive, because otherwise, if I change it in the tail recursion, it won't change, like, all the way in the front.
What is an atomic Boolean?
It's like a Boolean, but not primitive, basically. So if I say, like, Boolean bool is true, and then I pass bool to a function, like set
It
false.
won't change it. Yeah, it won't change it.
And then that
It's
function
basically
gets
a
correct.
Boolean
Think of
pointer.
integer. Think of integer with a capital I.
Exactly.
Yeah. Ah, okay.
Yeah. Okay. So we have.
You could use an array of booleans and then have it of length 1.
I'm not sure that's allowed.
Uh,
Okay. Let's see. What would be a good way to start with it? For some reason, I'm struggling a lot more with this exam than the last one.
Well, you're still on track for finishing it within an hour, so.
That's true. Yeah, we have already done like 2 of them in like, 40 minutes.
Does the helper method count as an auxiliary data structure?
No, you can use helper methods. I'm pretty sure.
Yeah,
At least.
just make a helper method.
Should.
And then for all other than you have that return a help method, because then the 3 is black. You only check in the first one, and then for all other, you just check the heap order property. You check that you can send a color of parent, for example, to check that no reds beyond each other. You pass up the depth, and you make sure that the depth of all children of both children are equal.
Okay.
And
so
then you
if
pass that through.
So if I have something like this. So first we would check like check if it's a kid. If so, check if it's black. Let's not say black kid. Let's say black external node.
Well, external nodes will be null, I think.
Oh yeah. No, every external node is black.
Yeah, but they're null.
Yeah, they are null and black.
Yeah,
but
black is if it's null, then it's black. I don't think they exist.
Yeah.
I think when you create an external node, you create it. Okay, because it has a boolean is red, so that's true or false. And I think upon creation of a binary tree, yeah, it will not set left.
Yeah, it will not set left. So if they're null, then
they
black.
are null.
Yeah. So does that mean that this thing inherently is true?
Yes, that is inherently true.
Bog. The children of a red node are black. Wait, can we do like? Oh yeah, we can do get left and get right. That's pretty sick. So we can say if in the wrong place here. If tree dot is red, then if tree dot has does you get left just return null if there's no left?
I would assume so.
Okay, so if tree dot get left is null.
But I'd recommend you add a boolean to the thing. So boolean is red or parent red.
Yeah.
Which one? To your method.
They can just check if this thing is red and the parent is red, then just return false.
And you also want to... No, wait, yeah. You want this to return a num.
A number?
Yeah, an integer, I mean.
Why?
Because you want to count the depth property, don't you?
Oh yeah, we want to do all of that in
smart.
one go.
Yep.
I see.
So you want it to
pretty
return
smart.
an integer, so that in the final one you check that the integer from both sides are done. So that one will return for each of them.
But it's
It will-
like that. It should only return the amount of. Let's see. Okay, real quick. First, I'm gonna. I'm not gonna use the. Git is red because I don't think there's a really good reason to.
No, parent is red.
Yeah, pass a boolean with
With the red
for the
with
parent
the
color.
red parent.
Why?
Because then your code is just a lot cleaner.
I guess. And here, let's see, is red, black tree helper, tree false. If
And then you just use -1 as the code for incorrect.
Yeah.
I'm really not a fan of using ints as like error messages, but at the same time, there's not really much of a better way.
There isn't a better
Creating
way.
a data structure for a result, but we're not allowed to do that.
Yeah.
Yeah, exactly.
Parent is red. Return -1.
You can. I just yeah.
Well, let's just do return -100 because
I do parent red first because you know that one.
3 could be null.
yeah, but if it's null, then we're not calling it.
Do you want to have that check in that level?
Yeah.
I'd say
I guess.
if 3 is equal to null, return 1.
Yeah, that makes sense. Yeah.
We can do it in this level as well, I guess. Whatever. That's cool. And now it doesn't matter which like.
Yeah, now it's all fine.
Yeah. So okay. Otherwise, well, we have this structure.
Yeah.
We have this structure. We have this structure. Now all you have to do is the depth property.
Yeah. So if
yeah. Okay.
if
So we
3
do...
is red. If 3
I
is
think
red.
actually we could do return.
Check if they're equal and not 1 or not -100.
Yeah, but you need your return dependent on whether or not it is red or not.
Yeah, but you can do. I think you can do integer dot parse int and then just the boolean 3 dot is red.
Yeah. Okay.
That will add 0 if it's red, and or actually let's do 3 dot is black, because if it's black then it will be 1.
Mhm.
It's 400 IQ.
Wait, but why do we do that?
This way that the depth will be added by 1 if it's black and by 0 if it's red. And we only care about the black depth.
But here. You want to check that you want to first check that the integer
The
red,
left
tree
and
is
right are equal.
Mhm.
Yeah, okay, that's a good one. So let's do if.
Probably assign those variables, because you're otherwise going to be calling them multiple times.
Yeah, that's true. Int left is this. Int right is that.
And don't forget to pass parent is red.
Oh yeah.
Into
that's a
your
good
helper.
one. 3 dot is red. Oh, forgot a comma. Okay, cool. If left is not equal to right, return -100. If okay, otherwise we just return. Now we know that
left.
they're equal, so now we just return left or right, doesn't matter. Plus if
Yeah.
this one is black. Okay, so this will be the return value. int return val is if return val, or let's actually just do return val is not -100.
This is like the least descriptive variable name.
Oh, thanks, man. Oh, damn it, we can't do that. Does Java have like syntax like this? So one if 3.if black
Yeah.
0.
But other way. Yeah, no wait.
Yeah, it's
Yeah. Other way around.
It is black 1 0.
Okay. Yeah, I can
Because it's
convert
your
boolean.
yeah.
Some.
Yeah, that's the best way.
What the fuck? Okay, cool.
Okay.
there are edge cases. I didn't expect it to be this high, by the way. There are some edge cases. So what if the case? What is the case that like, if both of them are -100? So what we can do
Oh
here,
yeah, we didn't put that in.
if left is -100 or right
And-
is -100, then we
or
also
just
just
and then not left more than 0.
Hmm?
If
No,
left,
it's
left
fine
is equal
like
to
this.
right and left more than 0.
This works.
This works,
I think.
but and that wasn't the issue.
You need to check if the tree is a binary search.
It is already a binary tree.
Yeah, but you need to
but that's
check if
not a
it's a
binary
binary
search
search tree. Yeah.
Fuck.
Yeah, that's one of the property that's.
It needs
not
the higher
listed.
lower relations.
Yeah.
Okay, we need to add the max and the min. We just add max and min to this method. Pass through. Yeah.
Okay, wait. So we have to make sure that every parent is bigger than its children. I'm honestly just gonna do this here, so we can say if.
No, that's not right. I think you need to check if the
You
left
need to-
child is smaller than the parent and the right child is bigger or equal to than the
Yeah,
parent.
that. And the
No, but
left
you-
child can be smaller than or equal, right?
Yeah.
No, you need a pass through because in case the child is smaller, but then the child is far bigger than the ancestor above it, you need a pass through value. Simple as. Because otherwise, you will have edge cases where it goes 2, 1, 3, and all those will be correct individually, but pass through they will not be correct.
Is that not okay in a binary search tree?
Nope.
Nope.
Because then you wouldn't be able to search it with binary search.
So this is page 460.
I mean, we don't have any speed requirements, so I would probably just make like a different function just to check if it's a binary search tree.
Ooh.
I would just put it in here. It's like 2 extra variables and 2 extra checks,
Yeah,
I think.
Is it?
Yeah, it is so little.
Okay, then never mind.
Because you just pass down the maximum value and the minimum value, and you check if it's between those.
Oh, yeah, that's true, of course, yeah.
I
haven't done any practice yet. I'm just gonna wing it tomorrow.
Oh
It
yeah,
should be
me too.
fine.
Yeah, same.
Int. So let's have an int max and an int min. So let's. Okay. So now we check. Kind of breaking my brain right here, but.
Just check if get value is less than the max and more than the min. And if it's not, return -100.
Oh, I see. Okay, if tree.get value is less than max or more than max.
More or equal to max.
No, but it's allowed to be equal to max, right?
No.
Okay. Oh,
I
because
don't think duplicate values are even allowed, are they?
I'm not sure actually.
No, you can't have same key.
Ah, okay. I guess that makes sense.
Okay, and what should the new max and min be?
Well, for the
value.
left side, it should be the
Value.
max gets updated to the current value, and the min just stays the same.
Okay, so this will be
And-
tree.get value, And the min stays the same, and the right side
And
should
the
be...
other way around.
Why?
So max, and then min.
Yeah, but it is max. The max will be 3.get value, right? That's what
Oh
you
yeah,
said.
for the right side,
because
it's the other way around.
The right side can go way bigger.
I see. So it should be like this, and then we have this value dot min.
That's the wrong way around, I think.
And I just try it out and then switch it up.
You see, I like that.
Well, this is
and
not gonna
it
work
should
because your
be
first call wasn't good.
3.
Also, you need to in the return left and right. Wait, no, because we're checking if left is more. They're more than 0. Never mind.
What is what should the original minimax be?
Infinity and negative infinity, or just
Integer
integers
dot
of
max
max
value.
value and min value. Since we don't really have, yeah. You might not want to capitalize integer.
Oh
like
yeah,
full
okay.
caps.
I'm kind of more the type of type something, run it, see if it works.
What difference have I made? to make mine false?
Yeah, because you need to
them up.
switch around those max and min in the left and right.
No, on line at 28 and 29.
Yeah, 28, 29, those are the wrong way around. Because the left side has to be smaller and the right side has to be bigger.
Yeah, but now the min and the max are still.
Yeah, you still have to
wrong.
fix.
No, yeah.
Wait, yeah,
Yeah.
minimum is on the left in this one. Yeah.
And mix.
Now it's a mix.
Oh.
Is that
And
less
we're
than we
right
had
back where
last
we
time?
started. This wasn't the fucking edge case.
Yeah, because the thing is BS. Wait,
No, it is the edge case.
Is it?
It is the edge case. In the implementation assignment, if you're missing is 3 binary search 3, you get 7. You can copy that from the implementation. You have probably done this one. It's from the previous part.
So that
Yeah, week 7. Yeah, this one. The second one, I think. Yeah.
Hey. Cool.
Hey, you get 90. Oof.
Do I?
Yeah, apparently.
Fuck.
Well, that's not gonna help that much.
Oh yeah, I think this was the one where I just said fuck it. Oh, but we're not even allowed to use it because this uses like in order list.
Yeah, you
Yeah.
use the previous one. But
What?
you can make it work with integer max value in min.
Wait, can you just go back? Because I want to see what I fucking. Somewhere I fucked up here. Something isn't working on mine.
Oh, you're coding along.
Yeah, of course.
Nice. You say of course, but I'm willing to put money on the fact that you're the only one.
Oh.
I tried it at first, but I just couldn't keep up.
Yeah.
I was kind of doing it, but I just got annoyed by it, so I stopped.
Sorry.
It's like either pay attention or type along, not both.
Yeah, understandable, honestly.
I guess, yeah. Oh. Definitely wasn't passing through value twice there.
Huh. It's still 72. That's the annoying part. Like, it was 72 before, right? Or was it more?
Yeah, it was
I
72.
think it was,
before.
yeah.
Shouldn't we do a null check?
We already have one.
Yeah, but it's not in
I
the.
found a problem.
Oh yeah, the
Line-
3 could be null there.
No. Line 25. No, line 27 right now. You cannot have both to be true at the same time. It should be logical or not logical end.
For which
Oh,
one?
that's true. Yeah.
Line 27.
Oh, yeah, I see.
Yeah.
That makes a lot more sense.
Oops. Oh, all of a sudden it works.
Wow.
We're just dumb.
One stupid or that's.
Yeah, that's all it takes.
Are we dumb or are we stupid?
Well, probably both.
Oh, this
Can
is
I
like a
interrupt
lot.
little bit?
Okay.
Can I interrupt a little bit? Sorry for that. Can you show me the implementation too? Really fast. I get 90 points, and that's really frustrating, and I really miss that part of the live. Okay. Let me
Oh,
take a
you're
screenshot.
if you get 90 points, that means that you are modifying the original array, which is not allowed.
Yeah, make a copy and then you're good.
Make a copy and then edit a copy instead of the real thing.
Oh, okay.
Yeah, we got the same issue, trust me.
Okay, thank you, man. Appreciate it.
You're welcome. Well, I mean, this is just. Okay, we
Just
need
do
we need to
Dijkstra.
implement Dijkstra. I mean, that's not too hard, right? Dijkstra has like.
Quite easy.
Yeah, we can just
Not the worst.
we can just go to like the week where Dijkstra.
Now it's gonna be mean if you're not allowed any auxiliary data structures. Then Dijkstra gets really mean.
No, it's like we are allowed to use adaptable PQ and PQ
Yeah,
entry.
should be fine.
Oh, you cannot use this class, but yeah. I see. They just casually throw 5 different fucking data structures at your face.
All the other ones are like a no data structure down here. It's like, oh yeah, just use all of them.
Now use everything you haven't used yet. Shortest paths.
Nah, just go code your own priority queue as well quickly. Come on.
Hup. Shortest path problem. Cool.
I mean, if someone actually implemented like their own like priority queue and stuff like in the thing from like memory or something, I'd give extra points for that.
They would probably set your grade to 1 because you're not allowed to use auxiliary data structures.
Yeah, but you are allowed to use primitives. So if you code your own data structure, then it's just a bunch of primitives.
Then you could argue it's still a data structure.
Yeah,
it's
but
just
then
what
your whole
you
function
made.
is a data structure.
Oh.
I mean,
But like in that case, everything's a data structure.
Yeah. Okay.
I mean, you
just use the primitives.
Okay, guys, we have Dijkstra algorithm. So this, and we also, I think he in the end gives like a code based.
Yeah, I was about to say we just want the.
Yeah, he gives the code at the end, I think.
Like I
It's also
understand
not hard
Dijkstra,
to implement from
I can do
this,
Dijkstra
but...
in my head, but.
Yeah.
Okay, pick the vertex closest in terms of weight to the source.
It just stores the vertex with its weight, and then goes from there.
Hey!
There's your code.
There we go.
Now go implement
Easy
this.
life. Now what we do then is I take a note. Wink. I will now proceed to not look.
Are we allowed to use the YouTube videos as well, by the way?
It's in Brightspace, so.
Yeah, we are allowed.
Fair enough.
It's an official study material.
Yep.
I mean, people with 2 screens just have a huge advantage now.
Yeah, I always have like hopefully I have like, my
I don't
my
have
laptop
any.
on this side.
I don't have like almost any screenshots. I just remember in which video stuff is, and I just really scroll through it fast.
Yeah.
And that's about
That's
it.
probably the best way to do it, honestly. Because otherwise you have to search through your screenshots.
I mean, that's a lot easier to search through your screenshots. It depends on how many you have, but.
For CO, I did do that, and it worked pretty well. But...
Yeah. Okay, let's. So we are allowed to use. Wait, actually, it only. Okay, it only says we need to use the Excel algorithm and the PQ that's in here, but it doesn't say that we're not allowed to use any other, right? So we can use anything else.
See it say any.
Yeah, and it even imports Java util star, so.
Yeah, and then it's like, yeah, go ahead.
Okay, let's see. So yeah, it starts out with int. Actually, can I put these on like the left right side like we did before?
You could, yeah.
The image is so bad, man. I think they made like a picture of a page. It almost looks like.
I think it is
they
actually.
might have just taken the picture from the book.
Yeah, it's a picture from the book.
Oh yeah, it is.
There's a curve to it.
Yeah. Oh, that might just be an optical illusion, but like YouTube does it, like it always like darkens out the borders like near the.
Yeah,
top and
you have to
bottom
take
for
a
some reason.
screenshot while you're not in the while your mouse is not moving.
Oh, that could be that's like because my mouse is in there.
Yeah. It is really hard to make one when not.
Probably full screen.
Okay, wait. So they have g.num vertices, and that's all the vertices in the graph, right? So what we can do is we can do graph.getAllVertices.size. Because we have to work around our limitations. Because their graph implementation is a lot more versatile than ours. And then a list of... I love this line so much. It's just like blah 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 PQ equals new blah 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 blah. There's so much text and so little actually being said.
And it's also just
Welcome
like
to
one
Java.
declaration.
Welcome
It's
to
like
type
it's
languages.
just one declaration at initiation. It's nothing else. No initiation.
Yeah, like you want to see how we do that? How we do that in Python? We say
A equals B.
PQ. Or
PQ is not defined.
yeah, okay. I guess we would say PQ is equal to
Well, yeah, or just a
yeah, or
actual
just
priority
like
queue.
yeah, new adaptable PQ.
Does Python have new? I don't think it does. I think you just call it.
Oh yeah, I think it's actually I think you're right. I've used classes in Python like once before.
Classes in Python are amazing.
They are. Integer, comma, vertex. Let's see. So we have.
I don't think you need to use that. I think you just need to
Yeah,
use.
we just have to do PQ entry.
No, not even that. No. Go back. It's a class. Just look down a bit.
So I think indeed you're right.
It's just PQ equals new adaptable PQ.
Yep, makes sense.
You've got them in the wrong order, man.
Yep, I saw.
One. No problem.
Okay, this it looks good. A lot better than the other one. So we create an entry of So here they create a list of all the. What did they use this for?
They store it. They use it to store the other, or the path. I think.
By the way, you're also trying to make a Boolean array of ints.
Ah, yep, good call.
That's fun.
Let's see. So they PQ tokens is what's gonna be. No, wait. They just return.
We don't need that actually.
Do we not?
I'm pretty sure that's used to actually resolve the path itself. But we don't need to resolve the path, we just need the length of the path.
Just length.
But I'm not sure actually, because here they say they use like PQ tokens V for other stuff. Let's see how far we get without it.
Yeah.
For vertex V in g.get all vertices.
I'd recommend maybe just doing the g.get all vertices and casting it to something, since you've used it now 3 times.
Who cares? It's just a variable in the class.
Let's actually do
well,
inside.
it's a
Because I only really care about size. Oh, I don't want to use fucking Radeon experience. Get away. Okay, so looping through all the vertices, what do? We say res with index v dot. What is our vertex get element thing? Get ID. Get ID.
Yeah.
Is equal to if v is the source. So the source is A.
Yeah, so just initializing the distances.
Yeah, so if v is just A, then 0, otherwise integer dot max value. Return 5. I kind of want to see if this code runs. Warning, 3 problems, 3 warnings. Let's go. That's a W in my book. So then we have this PQ tokens thing. But what does PQ.insert do? What is a priority? What is a heap adaptable priority queue.insert function return?
Well,
You
you
can
have
insert it in there.
this one returns void, in this case at least.
Yeah, but what is this then? An array of
Normally,
void?
normally you'd have with most of them, I think they return null if it fails. Otherwise, it returns the element, I think, or something like that.
Yeah, but in this case, it just doesn't.
Yeah,
but PQ tokens, that hasn't even been created.
Yeah, we haven't created PQ
No,
tokens yet.
we are just ignoring that for now.
No, wait, yeah, we don't need that. I don't.
Do we not need it though?
Because we have vertex numpairs. Or I guess.
The thing is that they use such cryptic fucking names that I can't understand what they mean.
The thing is, I don't think so. No.
You just want to go?
Yeah, let's just ignore it. We're gonna be fine without it.
Dude,
We should probably insert it into the priority queue though.
Yeah, that's a good one. So we can say PQ dot, and let's go scroll down a bit. And that will PQ as an insert or replace function.
That's kind of good.
And a vertex and a key.
Actually, do we want to? Do we want to insert every vertex into the queue?
Yeah, that's kind
Or
of
do
like
we only want to insert it once we get there?
No, this is like kind of the whole thing of Dijkstra. You just add everything and you just pick the minimum out of it like constantly, right?
Mm-hmm. Correct.
Yeah.
You always take the one with the
Yeah,
minimum
but since we
value,
have an
in which
actual
case-
source and destination now.
Yes,
No,
yes,
you
yes.
still do actually. Yeah, you still do. Yeah, never mind.
You should always take the
Oh
next
wait,
shortest
I
cumulative
see.
path.
So I think because this just returns an array of
All the
all the paths.
yeah, all the distances.
Yeah, and
of
we
the
only need
origin.
one of them, namely B.
Yeah.
I see.
But
So
you
we
still
can
need
work
to
around it.
calculate all of them because all of them could be part of that distance. We just discard them, but
But then we would have to create a list of entries of integer vertex integer of I'm not sure if that Wait, V oh yeah, V is the vertex. So we're creating is entry actually because I'm thinking
entry is map.entry.
Hmm?
That's an entry at least.
Yeah, so you guys want to just like try creating it?
Well, I'm working on it right now.
So we can have an entry between
99% sure you actually need to do map.entry.
Okay, cool, then we do map.entry between integer and vertex. And we need to do vertex, not vertex integer, because vertex is our own function or our own thing. PQ tokens equal to new entry integer, comma vertex.
The fact that we have a vertex numpair though, like we might have to use that.
A what?
There's
Yeah,
a
yeah, you
class
need
we
to
have
use that.
vertex numpair.
Called
no, that's gonna be useful using that instead. So just a
Yeah,
list
that
of
is
those.
what you have to use.
Okay, we're doing that.
Well, does it say you have to?
Well, basically, it's implied. Given that
It
it's the
doesn't say so, but it's exactly what we need. So we're
well,
dumb not to use it.
it's exactly what the PQ returns. So I'd say yeah.
I see. So now we can say PQ tokens equals, or PQ tokens V equals. Can we do this? Because V is a. How the fuck does that even work, man? V is a vertex. How can you index an array with fucking. So what are the things of the PQ Oh, it's not even in there, man.
What do you?
Oh
yeah,
wait, it
we're
is.
not working with a PQ token.
With PQ, I meant this one. But like here.
You don't need that either. I don't think.
Yeah, but still, like V is not.
Or
are all vertices just like numbers or not?
Vertexy. Okay. A vertex.
No, a vertex
has...
is V. Or
Yeah,
sorry,
V.
excuse me. V is a vertex, not a vertex of V. So PQ token V doesn't make any fucking sense because V is
No,
a
that's.
vertex, not a number.
I'm not even using the PQ tokens thing though. I really see no reason to use it.
But why else would you put it in there?
Honestly, no clue.
All right.
I'm just gonna check that.
Let's see how far we get without it. Then again, while PQ dot well, not PQ dot is empty. Vertex current vertex equals PQ dot remove min. I'm sure that's a thing. Adaptable PQ remove min. Let's go. Oh, this returns the vertex numpair. Okay, yeah. So this will be vertex numpair current vertex equals PQ dot remove min, and that has get vertex and num. Oh yeah, yeah. But then priority queue should be off. But that means our priority queue should be of should hold vertex numpairs. Oh wait.
Yeah.
Yeah, it's vertex vertex key. Okay, so that creates internally a vertex numpair from our two things. We can actually check that. So
Ah, there's the vertex numpair.
yeah. So we're looking for our adaptable PQ. Oh wait, I think I scrolled past it, didn't I? No, that's vertex. Get off adaptable PQ. And when we add something, swap, up heap, down heap, blah blah blah, bubble, insert. It creates a new PQ entry. Wow, these guys have way too much time.
Well,
whatever. So this is dot remove min, okay? Then we can say visited current vertex dot get ID, I think. So you can look vertex numpair. Vertex represents set of each vertex U stores a set of vertex numpairs. Vertex V of vertex U together with the weight of the edge between them. Yeah, but so we want to indeed use the get vertex as an index, but we're not allowed to do that. Unless the vertex is just a number, but it's not.
Well, vertex has a number as ID. So you can just do get ID.
Oh, vertex have an. Oh, that's actually, yeah, that changes a lot. So we can use vertex or get ID. That makes a lot of my code a lot more like sensical.
You've already used it as well.
Yeah,
yeah, you used it first, and then.
Yeah, okay, that makes a lot more sense. So visited is true. Yeah, so we take the current vertex, the current vertex numpair. We get the vertex from that, and we get the ID from that. Okay. Okay, and then we say for. I love how always they use like it returns edges and then outgoing edges and stuff, but this thing always returns like the what's it called? A collection instead. Yeah, get neighbors. So we can say for vertex num pair neighbors neighbor in current vertex dot get neighbors. And this will return an array of collection vertex numpairs. So then we have vertex numpairs, and then we can go through every vertex, and then we can say, if not visited v dot neighbor dot get vertex dot get id, and the result array, let's see, u is, so that is still current vertex. So the result array current vertex dot get vertex dot get id. I believe in the magic that this will surely work. And res u plus
I'm starting to work.
get element is just the edge weight. So that is current
Is it?
vertex dot.
Isn't it just the ID of the
No,
vertex?
because
Because
edge
they use
key.
it to initialize the result as well.
Mhm.
In the first for loop, they use get element as the index of the vertex.
But that doesn't make sense because here they add it to the current result.
What the fuck are they doing?
Who knows?
It wouldn't like. I wouldn't be surprised if this is all just wrong. But so far,
well,
DO vibes.
I like. Okay, well, I ran my first spec test. Expected to was integer dot max value basically.
all right.
That's always a good start.
Yep. It's less than res of v, and v is the opposite edge. So the opposite edge is for us just neighbor. Neighbor dot get. And what was the one we used? Get vertex, get ID. There's so many auxiliary data like things. So if this is true, then res current or neighbor dot get vertex dot get ID is equal to res current. Oh yeah, okay. When you see this line, everything makes a lot more sense. Get vertex dot get ID plus the current edge that we're going through. So that is e dot that is
Oh yeah, it's e dot get element. That's what it makes it annoying. Yeah.
Yeah, that's just neighbor dot get ID, because the get ID function returns the get ID function from the. Oh wait, actually it's not. It's get num when you're talking about a vertex pair. So it's vertex dot get ID and it's neighbor dot get num.
And I fixed my one bug and 88 out of 100.
That's good. That's good. And then we have pq dot replace key. So pq dot
Probably something to do with the pad not being there.
insert or replace.
Yeah, that's the one I haven't set yet.
Replace key, it says pq tokens v, but we've chosen to ignore that. So what do we put there then?
What?
They do at line 23, pq dot replace key, pq tokens v, res, but we don't have a pq tokens.
Well, why do you need a PQ token? You just use the ID of the vertex.
Yeah, okay, that makes sense. So
right?
then we have
Because yeah,
vertex dot get ID. I forgot brackets. Get vertex. And then we say insert at that place res neighbor dot get vertex dot get ID.
Isn't that just this one though? Oh no, no, that should be V. And V is.
Oh yeah. Oh, you're right.
No, V is the neighbor. V is the neighbor. Never mind.
Yeah, but then this should also be neighbor.
Should it? Yeah, it should be. Yeah, that makes sense. Yeah.
Okay.
You also have an extra thing square. Yeah.
And then for my last magic trick, I will say, now how do we get the res?
Well, res, you just get b.getID from res, and that's your
from res.
result.
Okay, yeah. So it's return
And
res.
check if that's max value, because then there's no path.
Yeah, true.
And I don't know what you have to do then, but
b dot.
Oh, -1.
Get.
Well.
Or actually, it's res b. Oh yeah, b dot get ID. And then we return if we return this if this is less than.
No, that's the first part of your thing.
Oh yeah,
you're putting it in the wrong place again.
I keep fucking it around because it's the other way.
Yeah, it's Python syntax what you're doing.
Exactly. If otherwise
-1.
Save your tests. Fuck.
Insert or replace.
We have 3 errors only. That's better than I expected, I'm gonna be honest.
And
so
it's
we use
on insert and replace,
it's
probably a typo.
And 100 out of 100.
Nice.
Probably 3 typos.
No, it's not a typo. I'd like to figure this out myself. So if you see something that you've struggled with that we don't know yet, give us some time to figure it out first. And if we don't find it after like a few minutes.
I saw it.
Well, can I just ask first of all one question?
Yeah, sure.
Java, if you try to add something to integer.max value, it will overflow. Will it? Or
Yes.
like it will?
Yeah, I think so. Could
Yeah,
be.
it will.
So will it change that value to be a negative value?
Yes. It will overflow to integer.min value.
Yes, so by checking integer.max value after it's tried to do shit, it's probably going to change that integer.max value because integer.max value plus anything will become less than
It
integer.max value.
shouldn't touch it if it's not a path, because it will never reach it.
No,
Right?
but you've queued every item.
Yeah, I guess that happens.
So you should probably check that if it's integer.max value, then you don't do that thing. And then instead visited isn't true.
So like this. So then -1 otherwise. So now we only check it if it actually is integer.max value.
Yeah.
Okay. Get neighbors is undefined for the type.
But I was more so thinking,
it's still gonna fuck up
in
if
the while
it's...
PQ is empty.
Give me a sec. I'm gonna figure the errors I have first. Because now I'm like looking at 2 things at the same time and that's not working.
Yeah.
You're checking vertex. Current vertex is still a vertex numpair. You need to get the vertex from current vertex. Current vertex is a VNP. Line 29. Line 29. You're taking a vertex numpair. You need to get the vertex and get the neighbors of that. Because right now you're getting a vertex.
Oh yeah,
vertex
okay.
numpair.
Yeah, because I'm getting a vertex numpair. Okay, so get vertex. Yeah, I thought you were talking about the other one. So I was like, what the fuck are you on
The
about?
top one is the order that's fucked up. You have to
Yep,
have it
so
the wrong way around.
insert thing is vertex then key. We're doing
Key then
wait.
vertex.
You're inserting the number, and yeah.
Yeah, you have to do it the other way around.
Okay. Okay, and last one, that's the same issue. So this is no wait.
And the fact that it's an ID, you just need to give it the vertex as well, I think.
Oh wait, in that case that might actually be.
Yeah, it's just because you put
get
ID at it.
Okay. And this one can go away. And let's see where our spec tests go wrong. Expected 6, but was 7. What about 55 out of 100? We take the W. Expected 6, but it was 7. That's for which one? That's for the test weighted. That's for which line? It's probably
63. It's in 63 at
what,
the
either
end.
this
but
one or
it's
this one.
Oh, that one. I thought it was 0.
Okay.
Well, the point is either way, it does something wrong.
Yeah, unfortunately. I would like to know which one of the two it is, so I'm gonna check. Okay, that means it's probably the bottom one.
And that one wants to go from 2 to 0.
Okay, yeah. So this one goes wrong. So it goes from 2 to 0. So it's 2.
It should be the first one. But what's the weighting? That's 7.
Let me actually edit this from here to here. It's 7.
Yeah.
Is there a better way? I'll do it with brackets. So this is 7.
Yeah.
From here to here is 2 to 4 is 4. Okay.
4 to 3 is 4.
From 4 to 1 is 1. From 0 to 1 is 1.
So yeah, you should be getting 6, but it should be going through all those generations.
Yeah.
You should have it print out the vertex ID and the.
At the end.
Yeah, print out vertex ID and the numbers at them, so you can see what each of them are. That would probably let you debug it easily.
So it is I, res I. So these are the values that Dijkstra's algorithm has, our implementation of Dijkstra's algorithm has found. Let me actually do it like print this and system.out.print line.
Nah, it's always satisfying when these work.
Yeah, it definitely is. It's a bunch of hassle to get working. And we have like, oh no, this is the last one. Okay, I was about to say we have like one more, but dude, Pog. I'm gonna comment the rest out because I just want to know it about this one.
Yeah.
Save your tests. Okay, so oh wait, I'm doing print line twice. Oh yeah, I'm doing n here.
Print and a new line. I was like, why is he doing that?
Okay.
Okay.
0 should definitely not be weighted to 7.
Let's have a look. So what should the numbers be? So 4 should be 4. That makes sense. 1 should be 5. That's correct too. But 0 should be 6 then.
0's getting
wait,
visited
wait,
before
check-
the rest, I think.
Check where it's updated. Check where it's updated.
Hmm?
Check. Okay. When you update the number, if it's not visited, yeah, if the neighbor isn't visited, and what's the the address current word is less than its current value.
Yeah. So if the neighbor plus the current vertex.
Mm-hmm. No, if
That should be neighbor, not current vertex there.
No, what? Because you're checking current vertex. Wait.
Yeah, I found it.
Oh
No,
yeah.
It needs to be neighbor.getNum.
Yep, you're right. You're correct. Motherfucker, spec tests. Motherfucker.
Boy.
Let's go.
Okay, I'm
We did it,
commenting everything
lads.
out. I want to go over the code one more time so that I properly understand what's going on, because I'm gonna be honest, I copied a bunch of it and I just didn't. Like, I was more focusing on trying to copy it than actually getting it working, which is not the spirit of these things.
Well, it was smooth now in the end. I don't know if I like how you wrote it, because that is
by the
so
way,
bad time complexity wise, I think.
I mean, this
we
is
have
just...
finished 2 exams in the time for 1.
Yep, correct. This one took... Yeah, we have.
A little bit longer, but it's
I mean,
still...
to be honest, we are with 16 people.
Don't forget the 7 minutes.
That's
Yeah.
true.
Well, the stale.
Yeah. Okay, that's. Then we are 2 minutes over our time because the other one.
No,
was
the other one
122
was
and this
running
is
for a couple minutes as well.
Hmm?
The other one was running for a couple minutes extra as well.
That's true.
And there was some wait time.
Yeah, but I only started it after that, I think.
And you went to drink some water in between.
Yeah, okay, but like the water is next to my desk, so
Ah, okay.
yeah. Okay. So let's see. I like the fact that we've also done it without PQ tokens.
Yeah, you don't need PQ
There's
tokens.
no
That's
need
what I
for
was
it.
saying.
I don't
That's
understand why
used
it's
for the
there then.
priority queue to update it, but our priority queue updates based on the vertex.
Hmm.
PQ tokens are already inserted because PQ tokens are basically vertex numpairs. But
I
we have an
see.
implementation of them already. So we need. So by adding it to the priority queue, that automatically happens. See?
This is so interesting.
But mine
Okay.
definitely.
Right.
Hmm?
I definitely. One thing's for sure. I have a lower runtime than you.
Yeah, definitely.
Can you scroll right a bit?
Yeah. Let me see.
Just full screen editor, I would say.
I hate the fact that everything is so. Even with full screen, we can't see it.
What the
Everything is
fuck?
so bloated because of this. Actually, let me just put an enter here. To let you know that these are like the two constraints, because then you can have a look at the whole thing. It still works. Yeah. Fucking hell.
Boom shakalaka.
Yeah. Okay, so we create the new res and visited array. Then we create a priority queue. We let's see. At the start, because we want res to hold our current length away from the node we're going away from. So that's going to be max value for everything except itself, which is when it's 0. And then we have priority queue, and we add the vertex v with as number infinity. And then while it's not empty, we get the min number. In the first case, that will just be any random vertex because or actually no, it will be 0. It will be like our first vertex because that's 0 and the rest is infinity. Or like the closest we can get to it anyway.
Well,
so that like our priority queue starts out grabbing A because that has a lower that has a lower this one.
Lower value.
Yeah, lower res. Yeah,
Lower
lower
key.
value away. So it's gonna get 1, and then it's gonna go for all its neighbors. If it's not yet visited, and that happens every iteration. So if it's not yet visited and this one is lower than the other one, then we update the neighbor vertex to be equal to. So let's see. Let me digest this one line real quick.
You really should just do some this like put some actual declarations
Some variables would clean this code
some
up a lot.
variables would clean that up so much because you just decided to go for everywhere you can just ...
Yeah, well the thing is I'm doing it the way they do it. Which is really fucking ugly.
True.
But you're not them.
That's true.
But they are grading it, so they're gonna get back what they gave us to practice with.
I highly
I'm
encourage
gonna make
everybody
them
to do it like
suffer.
this. If you wanna get back at them, I'd highly disencourage everybody to do this. If you wanna pass.
As they say at Apple, think different.
Yes. Anyone interested in sporadic access for their code? Just name every variable X with different Unicode symbols. Still gonna compile, it's not gonna be readable.
I made a challenge for my dad where I programmed in emojis because Python 3 supports Unicode.
Nice.
But yeah, that's our exam. I promised somebody I would go over the over my own midterm. So I'm gonna do that.
By the way, Joe, can you upload the 2 exam you did on GitHub maybe so I can study later myself?
I would say that's kind of hard because they're like in a web lab.
Yeah.
I mean,
I
only
guess
the
you could just
solution part. I
copy-paste
mean,
them
only the
into a
solution
file,
part.
but-
That's it.
Also,
Just watch the
this is
videos
gonna be
he's gonna
uploaded.
upload.
Yeah, it's gonna be uploaded to YouTube. Just
just watch
look
them
for
back.
it in the video.
Oh yeah.
Yeah.
Does that count as notes shared with other people? Everybody
put it in web lab.
Everybody gonna be committing
technic-
fraud in the YouTube comment section now.
Oh.
Technically, we could. This could be seen as like collaborative studying.
It is. I think it
is.
It is. That's
Yeah.
literally what we're doing.
Yeah. I'm gonna go over the over my own midterm. I'm pretty sure that's allowed.
Yeah, there's no reason it wouldn't be.
Yeah. So we had 4 assignments. Did anybody here not do the midterm?
Yeah, I had like no idea what to do because I didn't study at all.
Okay. Then this is probably gonna be good for you.
Yeah.
I like how we both did not get 100% on the exact same question and the
Yeah,
rest were
fuck
all...
arithmetic expression. That one was
Yeah,
annoying.
what the fuck's that last test case?
But what the fuck? Since when was a two-dimensional array not a fixed size array? I'm just asking.
Is it
Since
not?
when wasn't a two-dimensional array a fixed size array?
Wait, what do you mean? Is it not?
Apparently not, because I was using that for the message garbling because I felt like that's how I wanted to do it, and I
Yeah.
got failed on that one because it's not a fixed size array.
Yeah, but
I
no,
guess it's it's a fixed size array of fixed size arrays.
Yeah, and
Yeah,
they explicitly say are fixed size arrays of characters, not fixed size array of fixed size arrays of characters.
Yeah,
so I understand where they're coming from.
Yeah. In hindsight, I do agree, but like that one is such pedantics.
Yeah. Okay. So let's see. We have a message garbler, and the only thing we care about is this function. So for the person who hasn't seen the thing yet, basically what you're doing is you're splitting the array up into characters, and then reversing every m characters. So here it's every 3 characters, and then gluing them back together. That's all you have to do for this one. So I'm doing them in. So let's see. You have m, which is like the how many things you split it up into. So I go from 0 to the length of the message every m steps. So basically, m will be 0 here, m will be 3 here, m will be 6 here, and it's just going to be the next m characters from base onwards. Did I say m? Excuse me. So base will be 0 here, base will be 3 here, base will be 6 here, and then it's from base to base plus 3, base plus m in this case. But that's the part you have to shuffle. So then I have to check for overflow, because if we only have like here, these are 4 characters. If you only have 2 left, well then you're not going to be able to shuffle 4, because then you'll get a null pointer exception. So I'm checking for that here. Let's first look at it if that's not the case. So if we just have a normal case where you just have to swap 4 of them around. So what I do then is I let's see, blah blah blah. If
Did you actually do this fully in place?
Yep.
Damn. I couldn't be bothered.
Yeah.
Same. That's why I used a fixed sized array of fixed sized arrays.
Yeah.
I have 5 different helper methods.
My code is like really shitty, but it works. But basically, yeah, what I do is I go from j is 0, j is less than, or j is m divided less than m divided by 2. So what happens here is I'm swapping, in this case, the form swapping this one with that one, this one with that one. And the reason why you're doing j divided by 2 is otherwise you'll swap this one with that one, this one with that one, this one back, and you'll just have the original thing back. That's not gonna help. And then I just make a temporary character that's like the first one, swap the first and the second, and then say the last is the first again. So this is just in Python you would be able to do I closed
There he
Python.
goes again with his Python.
Yeah. You'll be able to do a comma b equals b comma a, but in Java you cannot do that, I don't think. So you have to create a temporary value. So that's what I do here. So these 3 lines are nothing more but swapping these 3 characters or these 4 characters or whatever. And then otherwise I create a new M, which in this case would just be 2, and I swap these 2 around then. And that's all that really happened for this one.
I mean, to be fair, using a helper method here would kind of make your code a bit simpler.
Yeah, the only helper method I could really think of though is like this one where it's just swap 2.
Yeah.
And then over here as well.
This is the
If you
exact
want to
same
see
for
what
each.
code with ridiculous amounts of helper methods look like, my stream. Including the min function, which is only used on this one line.
Why?
Wow.
Because I had it written with mat.min before, and I was like, ah, fuck, you can't use that. Oops.
Yeah.
So I did that.
Yours is a lot neater, but also a lot, like, it would have taken me a lot longer to code yours than it did to code mine.
Yeah.
Let's go to the next one. This is... No, this is... I'm gonna be honest, my implementation for this one was kind of sketchy. And
What did you do for it?
my brother explained how he did it, and it made a lot more sense. So he used a...
Well, why do I see a regex?
Yeah.
There's no... Oh yeah, there is a regex. So basically I check if it contains letters, then I throw illegal argument exception.
Ah, fair enough.
But basically what Yellow did was... he used a stack, and I used a list, which worked a lot less well.
I used a DQ.
Yeah,
As a
I used
stack.
I used an
Then,
array.
yeah.
I think I got flag complaint for that in the points. I think.
Yeah, I missed out on points because... Let's see, where is it? Oh yeah, I got everything they wanted. I just like got less than half on the spec tests. So let's not discuss my thing because I really messed this one up, and I was like, I'm gonna continue to the next one, and I'm just not gonna look back.
If you want, I could go over mine after this.
Yeah, you can do it afterwards.
It's
Yeah.
not perfect, but yeah.
Okay, this was really... I think this one was really, really easy. Because I had to implement down heap and remove max. And when you open the book...
They're literally there.
And look down heap...
Yeah.
There is a... Let's see, I think... Yeah, this one. I think this one was the one I copied. Yep, I did. I straight up line for line copied this.
Yeah.
And then the same for remove max. They use remove
They
min
did
here,
it
but I
from
did
the-
remove max. Because ours is like the other one. And that's it. That's it. That's the assignment. Merge sort, same thing. So for merge
Sometimes
sort,
these exams are literally just how well you can press Control F.
yeah. So for merge sort, for this one, normally what merge sort does is you split the array up into 2 parts, and then check if the length of the array is less than 1 or is less than 2, and if not, you split it up again, or if it is, you split it up again. Otherwise, you just have a sorted array. Coati sort is basically merge sort, but instead of splitting it up into 2, you split it up into 3. And so you have 2. It's recursive, first of all.
The hardest part of that one was legit just writing all the fucking cases for the bottom.
I mean, that wasn't too hard for me. That was just this.
It wasn't very hard, but it was still no. I mean for merging.
Oh yeah. Yeah, that's true. But yeah, what I did here is I have so you have the base case of if R is null, then you return null. If the length is less than 2, you only have 1 element, return R. And if n is 2, so if there's exactly 2 elements, well, you check first, is the one bigger than the other, then you return a new integer array of these 2. Otherwise, you return a new integer array of these 2, but they're just swapped around. So here I create 3 integers, first point and second point, which are the points of where I split my arrays. And then I use my copy of range, which is a function which copies an array from a first point to a second point. Yeah, and return that. So that way I can just sort each 3 of these individually. Then again, my copy of range is really easy. It's just a loop from start to end. Yeah, and I just... Why do I use count here, actually? Oh, yeah, because I is not necessarily 0 based. So yeah, I just create a copy here of all 3 parts, then I recursively call coati sort, and then you have a merge function. Like I think out of all of this, the merge function was the hardest, but I think I just
Without a doubt.
Yeah, I think I just swapped stuff around until it worked. So I have 2 indices, I and J, and I and J are the indices of the new arrays, or of the of the old arrays. Excuse me. So while I is less than A1 of length, so while we still have elements left in both of the arrays, then we check. Okay, is A1 at the pointer I less than A2 at the pointer J? If that's the case, then we set that element into new array. If
Oh,
not
so
the
you
case,
just merged 2 and 2, and you merged 2, and then you merged that one to the other 2.
Hmm?
You merged 2, and then you merged that with the last one.
Yeah, I do merge first part, second part, merge merge this thing with third part.
Ah,
like you do it in one go with all 3.
Yeah.
That's a lot harder to implement.
Yeah.
Yeah.
The same.
Yeah, no, I think
That's why I was saying that part was hell.
Yeah, I actually, now that you mention it, like, I thought I did that as well, but now I'm looking back and it's like, I didn't. So, I think I straight up indeed just used this.
Yeah.
And then I did this, and then otherwise, when one of the 2 is, then I just top them off, if you know what I mean. So, I do this until one of the 2 is no longer, like, has space left. So if this one isn't true anymore, that means there can be elements left in A1 or A2, and then I just top them off here, and then I just return the array, and that's it. And it gave me a 9.6 for some godforsaken reason.
What did it say was wrong with it?
The thing that was wrong was I got everything here except for the spec test. So if I got 100 on the spec test here, I would have gotten it then.
Yeah, you. Well done, I guess.
Yep. Anyways, I think for the YouTube video, that's where I'm gonna end it. We've been going for 3 hours and 20 minutes already. So a good session.
Which, considering what we've done, is way shorter than the exam.
Yeah. Yeah, I would argue that like the math stuff, we spent like 2.5 times as much time on that. That's like the amount of shit we did in this little time is impressive.
Fuck math. Fuck calculus. Let's just hope we pass.
Yeah.
I need 49. I think the grading system for that though is it's percent over 9 plus 1, so I literally only need 50% to get a 6.5.
You need if it's 1 plus grade over 9, then you need 50% to get a 5.5.
No.
Yeah, because half of 9 is 4.5, and you just add 1.
6.5 minus 1 times 9 will give you the percentage.
If you get 50%, you get a 4.5.
50%?
Yeah.
50% divided by 9 plus 1. 6.5.
Huh?
No.
50% divided by 9 gives you 5.555.
Oh, it's 9 divided by 50%, so 9 divided by...
Not 9 divided by...
Wait, okay, wait.
50 divided by 9.
So it's your score, that's 0.5, divided by... No, wait.
No.
50% divided by 9 gives you 5.555.
This is how we would do it in high school, and we use the same formula. So score divided by total is the percentage, so that's 0.5.
Yeah.
So if you get 0.5 correct, you get a 5.5.
Why am I dumb?
I think you are.
Yeah, well, it's
It
not
happens.
surprising. It happens a lot.
No worries, man.
But
very
like,
relatable.
I've been born into the system, molded by it. Because I've had to calculate shit like this all year in high school. I did multivariable calculus before you guys did, because I was calculating what 3 grades I needed for my German endterms. Yeah. And with multivariable calculus, I mean doing a Python for loop. So yeah, I think that's about it for the YouTube video. goodbye, everybody. I hope you do well on your exams. And if you have any questions, hit me up on Discord. Uriella4936, I think. And otherwise,
Yeah,
Telegram, Instagram,
maybe
whatever
I am
on
dumb.
Uriella.
Whatever. Doesn't matter. Let's just hope I pass, okay?
Good
I
luck.
I may be stupid.
Yes,
Yeah,
I am
that's it.
stupid.
All right. Have a good one, everybody on YouTube, and good luck on your test.